Waiting for me. হ্যাঁ আসেন স্যার আসেনি দেখেন তো লাইভে স্ট্রিমিং হতেছে না আপনি তাহলে জয়েন করতে পারেন হুম হুম ठीक है आपका फोन शुरू कर इस समय थोड़ी सुविधा हमारा भी दिख रही है
আমি স্টার্ট করব। Good morning. A very hearty and warm welcome to you all in this one-day international webinar on chemistry, recent issues and challenges towards our society, being jointly organized by Department of Chemistry, Women's College, Agartala, Tripura, and Department of Chemistry, Kabi, Nazrul, Mahavidyalaya, Sonamura. Before starting this auspicious occasion, I fold my hands before the light that brings prosperity, auspiciousness, good health, abundance of wealth, and destruction of the enemy's intellect. I fold my hands before the Lord, the maintainer of this creation, in the form of this light. I adore this light which destroys all the pains resulting from my omissions and commissions. Today, in this webinar, we are highly privileged to have with us Sri N.C. Sharma, Director, Higher Education Department, Government of Tripura, Agartala, Tripura, as the patron of this session. We are highly delighted by the kind presence of Srimati Manidipa Debbarma, Principal Women's College, Agartala, Tripura, and Dr. Uday Narayan Adhikari, Principal in Charge, Kabi Nazrul Mahavidyalaya, Sonamura, Tripura, as the President and Vice President of this one-day international webinar. We have with us a respected teachers from various departments of both the colleges. We are extremely delighted with the kind presence of the resource persons, the extremely talented speakers for the day from across the globe. And last but not the least, we are more than overwhelmed by the presence of all the participants from across the globe who have always cooperated with us from the very beginning. Once again, I heartily welcome you all in this session. Now, I would like to request Dr. Samhita Bhowmik, Associate Professor, H.O.D, Department of Chemistry, Women's College, Agartala, as well as the Organizing Secretary of this webinar to deliver the welcome address. Please, Madam.
Warm greetings to all. On behalf of organizing committee, I welcome you all to this webinar entitled Chemistry Recent Issues and Challenges Towards Our Society, jointly organized by Department of Chemistry, Women's College, Agartala, and Department of Chemistry, Kabi Nazrul Mahavidyalaya, Sonamura. We are privileged to have amongst us the patron of the webinar, Sri N.C. Sharma, Director of Higher Education, Government of Tripura. Sir, we warmly welcome you. Today we are extremely delighted to have three eminent speakers with us, Dr. Paresh Chandra, Professor, Department of Chemistry and Biochemistry, Jackson State University, USA. Dr. Amitabha Das, Principal Scientist, IICT, CSIR, Hyderabad, India, and Dr. Swapan Majumder, Professor, Department of Chemistry, Tripura University, Agartala. I, on behalf of Organizing Secretary and the Organizing Committee, welcome you all in our webinar. I welcome all the respected faculties and students who are participating in this webinar through YouTube streaming. I cordially welcome the President of the webinar, Srimati Manidipa Debbarma, Principal, Women's College, Agartala, who always gives us a constant support and inspiration to all our initiatives. I heartily welcome Vice President of the webinar, Dr. Uday Narayan Adhikari, Principal in charge, Governor, Nazrul Mahavidyalaya, Sonamura. I also welcome all my colleagues, academicians, technical team who are working behind the screen to make the webinar an eventful one, and dear students who have joined this webinar. Once again, I extend a hearty welcome to all of you attending our webinar. Before going to the technical session, it is my duty to introduce the theme of the webinar before the learned audience. We know that the applications of chemical science have contributed significantly to the advancement of human civilization. The post World War II chemists were considered societal problem solvers. They synthesized crop enhancing agricultural chemicals to ensure constant and viable food supply. They played a significant role in the eradication of deadly diseases by developing life-saving pharmaceuticals and chemical pesticides. Chemists have also developed innovative plastics and synthetic fibers for us in both industrial and consumer products. Thus, new discoveries have led to the improvements and benefits in our daily lives. It is through chemistry that we can make major contributions to the improve the quality of life and to advance the human condition around the globe. Chemical research and technology help us to solve many future problems. During COVID-19 pandemic, the knowledge of chemistry plays a key role in understanding everything from viral structure to pathogenesis, invention of vaccines and therapies, as well as in the development of materials and techniques used by basic researchers and virologists. Besides these applications, chemistry has some other issues and challenges to deal with, such as recent studies showed that the amount of plastic wastage generated worldwide since the outbreak is about 1.6 million tons per day, and approximately 3 billion single-use face masks or face shields are discarded daily as a result of COVID-19 pandemic globally. This may cause plastic pollution to the environment, and hence it is necessary to find a way to degrade them. A supply of energy is essential to the continued existence of human society, but we need alternatives to fossil fuels due to shortage. We are facing major consequences due to climate change. Hence, research and analysis is required to find out the cause and minimize the effect of these adverse conditions. World population is increasing rapidly day by day. It is essential to meet the food and safe drinking water needs for all. Identification and production of antiviral drugs and other medicines in a large scale at low cost for all. Cancer is a curse to our society, so more advanced research is needed in the field of chemistry with biological sciences on cancer cells as well as identifications of curable medicines. Finding chemical processes to conserve earth resources for the benefit and advance of our society is another recent issue. I am confident that the webinar will give us a fruitful knowledge about the recent issues and challenges of chemistry towards our society and some methods of solution. I hope for the grand success of the webinar, With these few words, I would like to conclude my speech. Thank you all. Over to Ipshita.
Thank you so much, madam. Thanks for being so enthusiastic. Thanks a lot. Now, I would request Dr. Uday Narayan Adhikari, Principal in charge, Kabi Nazrul Mahavidyalaya, Sonamura, Tripura, to deliver his speech. So please.
Namaskar. Am I audible, please?
Yes, sir.
Am I? Namaskar. Good morning. Respected President, Principal Madam, distinguished resource person from home and abroad, Secretary, Joint Secretary, members of the organizing committee, I would like to convey my heartiest thanks and best wishes to all. The organizing committee of today's international webinar, captioned Chemistry, Recent Issues and Challenges towards our society, has done me great honor by inviting me as Vice President over its ceremonial inauguration session. All of you present here are involved in the practice of science. But I am not good enough in science, not even a moderately knowledgeable student of science. I belong to the discipline of humanities. In such a situation, I am not worthy person to speak on the topic. Anyway, about topic, my point is, we live in the most advanced scientific and technological society in history. New discoveries have led to improvements and benefits in our daily life, but also to new societal problems. It is through chemistry that we can make major contribution to improve the quality of life in society and to advance the human condition around the globe. Chemistry is often called the central science as it plays a pivotal role in all aspects of physical and biological sciences, including engineering, agriculture, medicine, allied health disciplines. The industrial application of chemistry directly affect our everyday life. What we eat, what we wear, our transport, the technology we use, how we get electricity, how we treat illness, etc., etc. Chemistry will help us to solve many future problems, including sustainable energy and food production, managing our environment, providing safe drinking water, and promoting human and environmental health. Chemistry plays key roles for understanding viral structure to the development of chemical preventive measures and drugs for COVID-19. Our chemist friends, especially biochemistry, has responded quickly to the global pandemic. A collaborative approach not only between chemists and biochemical researchers, but also in interdisciplinary response among different branches of chemistry is essential. Besides, while discoveries in chemistry have made a huge impact and continue to have enormous potential, we also need to ensure that we use them responsibly to ensure sustainability in future. So, chemistry is not limited in the beakers, not in labs. It is all around us, and the better we know chemistry, the better we know our global. Once again, I thank everyone and hope the coming technical session will enlighten us. Thank you.
Thank you so much, sir. Thanks for being so supportive. Now, the presidential address will be delivered by our respected Principal Madam, Srimati Manidipa Debbarma, Principal, Women's College, Agartala. Please, Madam.
Am I audible?
Yes, Madam.
Respected resource persons, academicians, faculty members, my colleagues, and my dear students. Good morning, everyone. in the one-day international webinar on chemistry, recent issues and challenges to our society, jointly organized by Department of Chemistry, Women's College, Agartala, Tripura, and Department of Chemistry, Nazrul Mahavidyalaya, Sonamura, Tripura. We are delighted to have with us the Director of Higher Education, Sri N.C. Sharma, as the patron of the webinar. Sir, I cordially welcome you in this webinar. We are highly privileged with the kind presence of Professor Paresh Chandra, Department of Chemistry and Biochemistry from Jackson University, USA. Professor Amitabha, Principal Scientist, CSIR, IICT, Hyderabad, and Professor Swapan Majumder from Tripura University. I, on behalf of Women's College and on my own behalf, warmly welcome you all in this webinar. I extend my warm welcome to the Principal in charge, Kabi Nazrul Mahavidyalaya, Tripura. I welcome all faculties, research scholars, and students from different parts of the world who are joining us in the webinar through StreamYard. I also congratulate the faculties of Chemistry Department of both the organizing colleges and other members of the organizing committee who are working together for the successful completion of the webinar. Being the principal of Women's College, Agartala, Tripura, India, let me introduce our college to all of you. Established in 1965, it is the first college for women in Tripura, imparting quality education exclusively for women. Being a government college under the aegis of the Department of Higher Education, Tripura, and having 22 academic departments under arts and science disciplines, it is contributing significantly towards women education through a holistic and meticulous academic curriculum. As far as the knowledge or as far as the theme of the webinar is concerned, since the dawn of human civilization, chemistry has played an important role in our lives. Over the last 2 centuries, it has become an all encompassing branch of science. So, everything, starting from our day to day objects to components of satellite, are dependent on chemistry. Chemistry has helped in every sphere of industrialization, health, agriculture, etc. But even after so much progress, the human society is facing new challenges every day. Chemistry has the potential to solve the problems and is increasingly working towards it. The biggest problem that humankind is facing now is pollution and environmental degradation. Though not as widely talked about till a few years ago, we are now witnessing how fast the problem of pollution is increasing. Countries are already struggling to manage their natural resources, and overexploitation of non renewable resources is worsening the situation. One sector where chemistry is playing a huge role in the is energy sector. As an alternative to the use of fossil fuel, various chemical sources and alloy superconducting materials are being studied and used. Not only this, chemistry has also evolved in the last few decades to be more conscious and using environment friendly reagents. More and more research is now aimed at discovering environment friendly pathways to synthesize important molecules or compounds. Apart from this, chemistry also plays an extremely important role in various interdisciplinary applications, for example, the medical sciences. Chemical biology is a comparatively new branch which is becoming increasingly important in the process of treating various diseases and drug discoveries. Nowadays, research in this field is so specialized that even specific cancerous cells can be targeted without harming normal cells in the body. This is just one example, and there are hundreds of such applications which are a gift of chemistry to the health sector. The process of drug discovery has also been made a lot cheaper and faster because of advancement of research in chemistry. But there is still a lot of challenges ahead of us, like newer technologies are being discovered, but their application on a large scale is still limited in a lot of cases. With development in every sphere of life, newer challenges will also come along. Chemistry has solved many of the problems faced by us in the past and will continue to do so. With these few words, I welcome again you all and hope the program will be a successful one. Thank you.
Thank you so much, madam. Thanks for always motivating us to do the best things. In a nutshell, the webinar will make the students versatile and dexterous in today's competitive world. As such, change is permanent, so is the case with progress. One is bound to evolve and seek eternal satisfaction. Lifelong learners are happy, successful, and peaceful individuals who manages a healthy balance in distorting times like now. To be more happy and contented, don't let any way prevent you from your personal evolution. Take the brush and paint your life. Due to some time constraints, our patron for the webinar, Sri N.C. Sharma, Director, Department of Higher Education, Government of Tripura, is now unable to join. Hopefully, he will join within few moments. We will just wait for a couple of minutes. At the outset of this technical session, we will have with us Dr. Paresh Chandra Rai, who is currently working as a professor in the Department of Chemistry and Biochemistry, Jackson State University, Mississippi, USA. Dr. Rai has completed his PhD in 1997 from Indian Institute of Science, Bangalore, India. Dr. Rai was postdoctoral fellow in University of Chicago. He worked as a research associate in Columbia University and in Ohio State University. As a research scientist, Dr. Rai worked in Blacklight Power Inc., New Jersey. As the second resource person, as the second speaker for this technical session, we will have with us Professor Amitabha Das, Principal Scientist, CSIR, Indian Institute for Chemical Technology, Hyderabad, India. Dr. Amitava Das is working as principal scientist at CSIR Indian Institute of Chemical Technology, Ministry of Science and Technology, Government of India, and associate professor with the Academy of Scientific and Innovative Research, India. He has completed his PhD from CSIR Central Drug Research Institute, India, and postdoctoral research from Baylor College of Medicine, Houston TX, and Mayo Clinic, Rochester, MN, USA. He moved as an assistant professor in the Regenerative Medicines Division Department of Medicine and held joint faculty position at Biochemistry Division Department of Basic Sciences, Loma Linda University, CA, USA, before returning back to India at 2011. Lastly, we will be happier to have with us in the technical session Professor Swapan Majumder, Department of Chemistry, Tripura University, Tripura, India. We are extremely delighted to have with us Sri Ansi Sharma as the patron of this national webinar. I would now request Sri N.C. Sharma, Director, Higher Education Department, Government of Tripura, to say few lines. So please.
Am I audible?
Yes, sir.
Yeah. I am sorry that I could not attend in time due to some other assignments. After that, I could not get the link also. Okay. So I am delighted that I have been given a chance to share something in this August seminar, international seminar, and which is the need of the day. I first want to congratulate and welcome the distinguished uh, personalities from outside India and also from Tripura. Professor Paresh Chandra, Department of Chemistry, Physics, Jackson University, USA, and Professor Amitabha Das, CSIR-IICT, Hyderabad, India, and Professor Swapan Majumder, Department of Chemistry, Tripura University. I, on behalf of Higher Education Department, Tripura, I offer my warm welcome to all of you, and Madam Manidipa Debbarma and the Principal of Sonamura Degree College, Uday Narayan Adhikari. They have organized such a good program for the betterment of the faculties and for the students of Tripura who are studying chemistry and other subjects also. Now, the caption of this seminar is very, very important. That is the chemistry and the society. And as all of you know, that the chemistry is related to all aspects of life. When we talk about our foods, when we talk about our environment, when we talk about our clothes, when you talk about the recent developments throughout the world in terms of environment, pollution, and even in different kinds of diseases, all things are related to the chemistry. So exploring chemistry is the need of the day, and how it can be utilized for the betterment of the uh, society. As you are all are from the scientific arena, that the society, human, particularly the human society, and the human society is not going in a smooth way. It is a very tough days nowadays throughout the world. The society is facing. Recently, as you know, that we are uh, going through a pandemic situation throughout the world due to uh, chronic COVID-19 effect. So this is also area where the chemistry subject is very important. Throughout the world, the scientists have been working on this matter day and night. Though they have improved many things and developed, innovated many things, many medicines and vaccines, etc., for combating this disease. But we have to go to the root of the cause, because as you know, all the due to the human intervention, the normal global situation is being changed day and night and day by day. So due to industrialization, due to changes in the environment made by the human beings throughout the world, particularly the those who are more developed, those who are not directly connected with the nature, we are disturbing the nature. And that's, as you know, that every work, uh, that is, action has the reaction. So what I feel that this is the reaction of the environment, what we are facing now. The environmental strata has been changed, the environmental conditions have been changed, the particles of the natures have been changed, the in the molecular level, day by day, it is changing also. So you are working, that is right, but we have to work hard to find out the root cause of the devastating nature. Otherwise, the in a lot otherwise in the future, our human society, human beings will be in a trouble, and the repercussion of the environment, repercussion of the that is nature, it will be very tough for the human beings to uh, face. So this is the time where the policy decision should be taken by different countries, so that the scientists can work freely and they can explore the root cause of the different incidents which are being faced by us. Uh, One burning example is the spread of COVID-19 throughout the world. So these are the things we have to explore. The scientific world should explore to how the nature can be given the space to rectify, so that the people, society, that is people and other animals also get their scope to live in a natural way. We should not be involved more and more to change the nature. We are thinking that it is we are changing the nature in our favor, but we do not see that this is going in our disfavor. So these are to be explored by the scientific world. That means the scientists who are working throughout the world. So that's I feel that's I feel it is the need of the day. In our Tripura aspect, it is a small state, and you are all are, I think, from Tripura. You are also working in different places of the country and as well as abroad. In our Tripura aspect, research facilities are less, and the students, I think that being a small state, the students are very that is enthusiastic, and if they get scope, they will be able to work more and more. So, who are working from Tripura, I request to you that you make a scientific group with the national and international scientists. So, because it is now the world has become more and more smaller, and we are well connected with all the experts of the world who are working in different good and advanced institutes. So this is the day we can work with them, and we can supply them the that is um, what we supply them the sources from, or the that is information from our state, so that on these matters and the scopes they can work. For example, for chemistry, suppose we can collect the data from our villages, from our different areas of the state, and these data, and if it is required, the materials we can send to them, and they will work on this, and this, after analysis of the data, what is required for rectifying the environment and rectifying our that is other aspects, they can suggest us, and we can apply this in our state. So if these kind of groups are formed with the experts, of international experts and national experts, then our students and our faculties will get chance to work in this small state, and our society will be that is benefited from this. So this is from my side. I request all the experts who have joined here that please help our students, our faculties who want to work on the subject, but they are not getting sufficient scope for work. So you come also and guide also how to work and what are the requirements for working, and how will be used, you will be able to use the chemistry for societal development. So these are the things what I feel. I request, rather I appeal to the experts, work more and more for the betterment of the society, and explore the maximum use of chemistry in the betterment of the society. With these words, I congratulate all of you for joining this program, and I hope that this program will boost up our mental strength and our that is working atmosphere in the state and in all the colleges of our state as well as universities. So with these few words, I thank you all again for giving scope to say something about on the matter. I am not the expert in this field. What I have felt, I have just discussed, and that is placed before you. Thank you all.
Thank you so much, sir. Thanks for your valuable words. Now I would request Dr. Amitabha Saha, Assistant Professor, H.O.D, Department of Chemistry, Kabi Nazrul Mahavidyalaya, Sonamura, Tripura, who is also the Joint Organizing Secretary of this webinar, to give his vote of thanks. So please.
Good morning, everyone. Honorable Patron, eminent resource personalities, Principal of Women's College, Principal in charge of Kabi Mahavidyalaya, dear students, esteemed colleagues, learned participants from different areas. We have come to the end of inaugural session of our one-day international webinar on chemistry, recent issues and challenges towards our society. Myself, Dr. Amitabha Saha, on behalf of Department of Chemistry of Women's College and Covid Mahavidyalaya, Sonamura, organizer of webinar, thank you all for your overwhelming participation virtually. It has been a great honor and privilege to propose vote of thanks to our honorable patron, Sri N.C. Sharma, Director of Higher Education, Govt of Tripura, for accepting our invitation and also for his valuable words our one-day international webinar. I express my deep gratitude and respect to Dr. Paresh Chandra, Professor, Department of Chemistry and Biochemistry, Jackson University, USA. Dr. Amitabha Das, Professor, CSIR-IICT, Hyderabad, India. Dr. Swapan Majumder, Professor, Department of Chemistry, Tripura University, India. Eminent resource personalities for their consent to be a part of this webinar. It will be a pleasure to hear from you all, sir. I would like to thank our President, Srimati Manidipa Debbarma, Principal Women's College, for motivation and guiding us to organize the webinar. Also, I would like to thank our Vice President, Dr. Uday Narayan Adhikari, Principal in charge, Nazrul Mahavidyalaya, for his benign help in each and every step for organizing the webinar. Last but not the least, I express my sincere thanks to all participants of the webinar from different areas, including dear students. Thank you all.
Thank you so much, sir. Thanks for being so supportive. Now, this is the time for the much awaited technical session where the extremely talented resource person from across the globe will share their valuable words in this one day international webinar on chemistry, recent issues, and challenges towards our society. At the At the outset, we have with us Professor Paresh Chandra, Department of Chemistry and Biochemistry, Jackson State University, USA. Dr. Paresh Chandra is currently working as professor in the Department of Chemistry and Biochemistry, Jackson State University, Mississippi, USA. Dr. Rai has completed his PhD in 1997 from Indian Institute of Science, Bangalore, India. Dr. Rai was postdoctoral fellow in University of Chicago. He worked as a research associate in Columbia University and in Ohio State University. As research scientist, Dr. Rai worked in Blacklight Power in New Jersey. Professor Rai has won a number of awards. $1 Million Grantsmanship Award for 6 times, JSU Best Innovator Award for 3 times, Material Science Innovator Award, Mahatma Gandhi Pravasi Samman Award, Indian Mississippi Innovator Recognition, JSU Researcher of the Year, JSU Chemistry Best Teacher Award, National Science Foundation Recognition for Material Science, Sir J.C. Ghosh Medal for Best Thesis Award, and many more. Dr. Rai is editor for book series Photothermal Therapy, Mechanism, Efficiency, and Future Direction, Food Poisoning, Outbreaks, Bacterial Sources, and Adverse Health Effects, Colloidal Classification, Properties, and Application. He has also been associate editor for the Journal of Bioscience and Medicine, Journal for Nanotechnology, editorial board member for Journal of Nanomedicine and Nanotechnology, Journal of Environmental Science and Health. In total, Professor Rai has 167 publications in his credit. It's a great fortune to have with us, sir, in this webinar. Sir will be saying about bioconjugated nanomaterial for targeted diagnosis and inhibition for COVID-19. Sir, please, platform is all yours.
Thank you. So let me share my screen so that I can share my seminar to all of you. So first of all, thank you all for giving me opportunity to share our group work, what we are doing in this pandemic time on COVID-19. The disease name is COVID-19, but the actual virus is SARS-CoV-2. Now, why I have taken this? Because the title of that seminar is the challenges towards our society. So next page, what I'm showing you, the recent article came out in Times where it shows that more than 70% of those survived placed in the pandemic is a top issue facing our country today. So this pandemic, current pandemic is COVID-19, is mainly due to the virus called SARS-CoV-2. So I thought we can discuss and how the SARS-CoV-2 happens and what are the pandemic happens in this world and how as a chemist in Jackson State University we're trying to do something to work on this area. So before moving more, let me show the real player, my student, postdocs, and others in our group who really worked hard for this type of research, and the funding agency who gave me the funding for to do this research. So this is the actual player. I just gave a lecture in this, but these are the student and postdoc who really did the work, and that is why I can present in front of you. So as we talk about the coronavirus, we know that current global pandemic is due to the SARS-CoV-2 virus is responsible for over 5.4 million deaths till now. So this is, we all know now, whole world is suffering not only for health, for everything. We really cannot come back to our original day. So now let me tell you that this virus, which is basically a SARS virus, is not new. It started from 2002, the first reported. In that case, we have a total case around 8,098 and 17 countries, and total days was 744. The next time the world has seen this SARS virus as a MERS-CoV, that time it was 2,500 people were infected, and the total people killed was 860. And now, as I showed you, 2019 came as a COVID-19, and the reported case is very, very high, and death is several million. Just data I showed you in the before stage. Now let me give you that. Though, in this generation, like you, I am also in this generation, we talk about COVID-19. But really, this pandemic is not the new. Think about that. I gave you the history of the pandemic. The pandemic, even we all know plague 1347 to 1351, which really killed 200 million people. And if you think about that 700 years before, the amount of people was much, much lower. But that time also pandemic came, which is Black Death by a plague, killed 200 million people. And now next biggest plague was smallpox in 1520. It killed around 56 million people. Even very recent, we all are suffering HIV/AIDS, which also killed 25 to 35 million people. So this data, basically, I just want to show you that the pandemic is going on even before 1300, even much more before the data maybe we don't have now. But this is continuing COVID-19, which killed around 5.4 million, which is really much, much less from HIV/AIDS or Spanish flu or smallpox and any other time pandemic came and killed the people. So only thing we have to know how to survive in this way, so that we should have a vaccine and so on. So a lot of people are working on this, and I'll discuss more and more with time. So let me tell you about the SARS-CoV-2, which basically cause for the COVID-19 disease. So this is basically the virus picture. This is you can see that this is a RNA virus. You have RNA is inside, and outside you have a S protein is the spike protein, and M protein and E protein is the envelope protein, and so on. But you have heard all the time about the spike. You don't heard all other proteins that much, because this is the protein is a very important for this virus to infect in the human body. So if you see, the spike protein of coronavirus has to bind with the ACE2 is an enzyme protein on the surface, mainly lung cell and other cell in the human body. So when the spike protein bind with this ACE2 enzyme, and it goes inside the body and release the RNA, and through that we infected very highly. So that is why lots of work going on, that how I can stop the binding between the spike protein of coronavirus and ACE2 of the cell surface of human body. So that's the challenge everybody is talking about. That is why everybody talk about spike and spike and spike, because spike protein is the main protein through which this virus enter to our body. So our
Sir,
vaccine, yes.
sir, sorry for interrupting. Sir, I just want to know if you have shared something, the screen or something, because
Yeah,
it's
so
not.
you cannot see the sharing screen.
No, sir.
Oh, 1 minute. Let me see where is the mistake. So let me try sharing again. How to share? Share. How to share? Mhm.
That screen, right?
Mhm.
Now you, so you can you tell them that
Yeah,
is
now you can see.
Yes, sir. Yes, sir. Thank you.
Okay, so sorry. Let me go back again then. Okay, I'm sorry. So let me start a little bit at this thing. Okay, so this is our group member who really did all the work, and I'm just giving the lecture. And you can see that this is a funding agency from the NSF DMR Prime, NSF COVID-19, NSF CREST, NIH RCMI, and DOD, and so on. Now, I started with this, that the current global pandemic with the COVID-19 is mainly due to the virus called SARS-CoV-2, which is responsible for 5.4 million deaths till now. Now, I discuss also this, let me discuss again, that though we all think COVID-19 is new, but the virus is not new. The virus came first in 2002, where number of cases was 8,098 and total death was 744. And then again, we see the same virus in 2012. Case was 2,500 and number of people died at 860. And now, as you know, several million and even number of deaths is 5.4 million. And till 2022, we don't know how many days it will be here. So we all are suffering on that. And then we discuss history of pandemic. So think about that. Though we think that COVID-19 is the pandemic in our generation, but the pandemic is not new. Pandemic started even very, very early. I'm just starting from 1347 to 1351, when 2,000 million people died due to the Black Death or plague. And then bigger pandemic was smallpox in 1520, which killed 56 million people. And then think about even recent days, HIV/AIDS, another pandemic which killed 25 to 35 million people. And before that, you have a Spanish flu in 1918, 1919. For 1 year, it killed around 40 to 50 million people. So this data, basically, I just want to show that though we think COVID-19 is, we all are suffering, but this pandemic came in this world again and again all the time. So what we really need to see how to prepare for this type of pandemic so that general people don't suffer with this type of pandemic. So next I started that talking about what is this virus, the SARS-CoV-2, which is the causing the COVID-19. So this is a virus which is called RNA virus, like HIV virus. So this RNA, you can see that RNA of the virus, and outside you have a lot of different protein, S protein, M protein, N protein, but we always talk about spike protein. S protein is the spike protein because spike is the main protein which help this virus to go inside the body. So the mechanism is like this. This virus has a spike protein which bind to the ACE2 is the enzyme protein in the cell surface, mainly in the lungs and so on. So this bind to the ACE2 by a spike protein inside our body, and then it releases the RNA through which the COVID-19 spread in our body. So if we can stop this binding between the spike protein and ACE2, then we can stop the infection of the COVID-19. So that is why you all always see that people talk about spike protein. So the vaccine, and we just started, and then I understand that you have not seen this. So the vaccine, I'm talking in US, we got the mRNA vaccine. This may not be true in India. They may have antibody vaccine. I'm not that knowledgeable on that. But let me talk about what we have seen in mRNA vaccine in US. So when the people have been taken the vaccine, this mRNA goes inside the body and make the antibody, which is called anti-spike antibody. So this antibody, when the virus come to bind to the human ACE2, before that, this antibody is supposed to bind to the coronavirus. So that now spike protein cannot bind to the ACE2, so it cannot infect the human being. So that's the way antibody, the vaccine works. But the problem came with time. As we know, if you allow the virus to stay longer time in this world, they will mutate. That's the way every virus. This is not only true for coronavirus, even flu virus, every virus, they mutate if you allow them to stay a longer time, because we all know the fittest survive in this world. That's what Darwin says longer back. So same thing. So with time, what happening, the virus is making all different type of strain. So it started with alpha strain. It started in the United Kingdom, beta strain in South Africa, Delta strain came from the India, and Gamma from Brazil. And now we know we all are suffering on Omicron. It started in South Africa. So this different strain, when they make, they modify the spike protein. Because virus understood that if they don't modify the spike protein, the vaccine will not allow them to survive here. So that's why they modify the spike protein. And as a result, with time, the spike protein cannot, the antibody making by this vaccine is not, I'm just showing you different type of mutation. Let's forget all this thing. I'm not coming details on that now. But what I'm saying that this type of different strain when came in the market, our antibody is not working very nicely because it's reduced the sensitivity of SARS-CoV-2 variant Delta to antibody neutralization. So that's a well-known fact, and that is why now USA started booster dose. I'm sure India and others also talking about booster dose, so that our antibody has to increase to fight with different type of variant. So that's the way our vaccines were going on in this world. Now let me tell you what we are doing. So number one, we all know that number one stage has to be, we have to find out whether anybody has been infected by the SARS-CoV-2 or not, by COVID-19 or not. So early detection of SARS-CoV-2 infection is a key for controlling the pandemic, because we all know once people are infected, they have to have it in the home so that they cannot spread. But if you cannot find out that people have infected, then they will go everywhere and it will spread. And that's the way you can only controlling factor is detection in early stage, so that we all know how to separate them from the other human being. So there is a lot of technology has come out in last, I'll say more than around 1.5 to 2 years. All different type of research has been done, other group, including our group. So let me give you a couple of technique people are using, which is traditional technique everybody use. One is called PCR, or called polymerase chain reaction. Now we all know that this is one of the best technique available in the market for anything. You want to do virus, you want to do bacteria, you want to do disease, everything. PCR is the called gold standard technique. Medical people use all the time. The main problem is it takes several days to get the result, and because you have to take that sample, and then you have to separate the virus, and then they have to take out the RNA, and then you have to find out this RNA match with the COVID-19 RNA or not. So that stage takes, I know in USA, most of the time 2 days. And in 2 days, if you cannot tell somebody you are infected, maybe he or she can infect another 100 and 1,000 people in 2 days. And that's the problem everybody is facing, how to stop the spreading the infection. So that, and for that, what we need really, can I detect very, very early and mass scale production. And both are very, very much necessary to stop this infection. So another test, maybe in India also it's common, called COVID-19 antibody test. But they remember that this test is only tell you have been COVID-19. It can be even 5 days before, 7 days before, even after infection. So that's the main problem of antibody test. Sometimes antibody test may say you are not, because it takes several days or several hours to get the enough antibody in our blood, so that we can find out the antibody test. So that is why people are looking for how I can do much faster rate this type of test. So let me tell you what we have done last 1.5 years in this area. So our group is working designing the bioconjugated nanomaterial for the detection and inhibition of coronavirus or SARS-CoV-2. So this is, I'm just showing you, our group works on a lot of different type of nanoparticle. We work on gold nanoparticle of different size and shape. We work on graphene oxide. We work on lots of different fluorescence nanoparticle. We also work on CNT and so on. So just to show you that all different type of nanoparticle we make for all different type of diseases, not only COVID-19. Last 10 years, our group has developed all these type of nanoparticle. And then we make bioconjugated nanoparticle, because we make sure that our technique is highly selective. Because in biomolecule, always selectivity is a very, very important issue for anything to making for sensor. So this is, I'm just showing you our recent couple of, we published 2 papers, and 2 more will come out soon. One of them become the cover page in Journal of Physical Chemistry later, and another was in cover page in Nanoscale Advances. And this is the 2 paper, I'm just showing you the cover page of that. So let me tell you how we did that. So the first stage, what do? We make gold nanoparticle. For that, we start with iodic chloride and then 6 molecule. And who does nanoparticle, they know this is a very, very simple reaction. Even high school student works in our group who can make this type of nanoparticle very easily. And then what we do, the first step, we take this nanoparticle and make it highly stabilized and biocompatible by putting the PEG lesson or polyethylene glycol polymer. And so once you add the polymer on the backbone, they're highly stable and biocompatible. And then we use the antibody or aptamer, any of the bioconjugated molecules, so that makes sure these nanoparticle only bind with the virus we want, not anything else. So that is why we use a lot of different chemistry to attach this antibody or aptamer with the nanoparticle. One of them is EDC NHS coupling chemistry. Now, once we make this nanoparticle, then we detect the antigen. And for the detection of antigen, what we use the technology is like that. So in presence of antigen, the antigen antibody interaction, the gold nanoparticle aggregate. And once they aggregate, you can see before aggregation, they had a pink color, and then after aggregation, they have a blue color. So just by seeing the simple colorimetric change, we should be able to detect the coronavirus. And that's the theme in our research, and that's how you're working. So this is antigen detection. Similarly, you can detect virus, coronavirus, and you can see in case of virus, since this virus has lot of protein, spike protein outside, so this anti-spike antibody will bind to the spike protein, and as a result, again, you can see nanoparticle can bind, and that is why you can see the color change. So our detection technology is just simple color change. We can detect whether it is COVID-19 antigen or SARS-CoV-2 antigen or virus is there in the sample or not. So this is, you can see, this is TM image of nanoparticle before COVID virus, and after virus, you can see if you have a small amount of virus, they started aggregating, and if you have a high amount of Again, amount I'm talking about 1 nanogram per ml. This is really, really small amount of virus antigen we can detect by this calorimetric study. And you can see the TM image clearly since they aggregate in presence of the antigen, and that is why we are able to detect from the calorimetric study by this type of virus. So this is, you can see that. So even when the amount of antigen is 1 nanogram per ml, we can see clear color change. Even 0.8 nanogram per ml also we see some color change. So this simple calorimetric change assay we have shown that can be used for the identification of coronavirus SARS-CoV-2 antigen. So this is the absorption spectra, what we are showing, what you are observing. So you can see that usually gold nanoparticle has a strong absorption at 520 nanometer. And then once in presence of this virus antigen, due to the aggregation, the peak shifted, always rate shift, always it well known. So it goes from 520 to around 600 nanometer, and that is why you see the color change. So this is, you can see clearly in the absorption spectra, the shift of the absorption in this case. So now the always question, as I say, that in case of biological molecule selectivity, how I am sure that I only did a COVID-19, not anything else. So for this case, we have taken COVID-19 spike antigen, COVID-19 nuclear protein antigen, and MERS-CoV nuclear protein antigen. And you can see that only in case of spike antigen, we see the color change. So this clearly says that our technique is highly selective for the spike antigen, but we cannot separate other type of antigen from this type of technique. So clearly we have shown that this calorimetric change using bioconjugated gold nanoparticle can be used only for the detection of spike antigen. So now we look for, can I do for virus? So this is a virus case. You can see even if somebody has a 1000 virus, we should be able to detect them by this simple calorimetric study. And you can see the similarly absorption spectra, and you can see that absorption spectra also clearly shows that we should be able to see that up to some completely change of the absorption state from 520 nanometer to 600 nanometer in the presence of virus. So this is, we saw the completely detection of virus or virus antigen using bioconjugated gold nanoparticle, which you can see in the eye. So this is, I'm just showing TM image of the virus. You can see outside spike protein very, very nicely. In absence of nanoparticle in the left side, and the right side, you can see in the presence of nanoparticle, and you can see those nanoparticles went to the bind to the virus. And this binding mainly due to the antibody conjugated with the gold nanoparticle, which bind to the spike protein of the virus. And that is why you can see the virus can bind, the nanoparticle can bind with the virus. Now, virus is usually, you can see it is less than 200 nanometer, and nanoparticle is 20 nanometer. So you can see several amount of nanoparticle can go and bind to the virus. So next we moved, can I do fingerprint identification of virus using surface enhanced Raman spectroscopy? We all know Professor C.V. Raman got 1930 Nobel Prize from India. And so since I actually did a lot of work on surface enhanced Raman spectroscopy as an Indian, I always believe. So that's one of the area is really important for us to grow more and more. So can I use this Raman spectroscopy for the detection of this coronavirus? So I'm not going more details about the Raman spectroscopy. Only problem in Raman spectroscopy is that it's very, very weak because this is scattering technique. And that is why later people move from Raman to call surface enhanced Raman, where you need to have this type of particle surface like nanoparticle surface. It can be gold, silver, and other nanoparticle. And then once you use this surface and then put a molecule, you can see a huge enhancement of the Raman signal, which is called surface enhanced Raman. I'm not coming more details on that now. And we and others have done a lot of work on that. And so that enhancement can be 10 to the power 8, 10 to the power 10 magnitude. So as I said that our group has done several work on this, and I'll say last from maybe 15 years, we have published several articles, including JCS, Chemical Review, JPC Letter, Account of Chemical Research, and so on. But today's lecture, let me give you what we have done last couple of months about how to use this Raman spectroscopy for the detection of COVID-19 virus. So this is the way we have done. We have used para-aminothiophenol as a Raman reporter, which has been attached through SH bond to the gold nanoparticle. And then, in presence of nanoparticle virus or antigen, as you saw before, that nanoparticle aggregate, which help us to get a very high signal. So you can see that as you increase the concentration of antigen in picogram per ml, picogram means 10 to the power minus 12 grams, a very, very low concentration. Even we can detect in this technique. And then, since this technique, as I said, that this is one of the most sensitive technique available in the market, and we have shown that we can detect even in picogram level antigen by using this technique. Similarly, we have shown that can I separate different antigen from COVID-19 antigen. Again, you can see that we can see that only COVID-19 antigen, the signal enhancement is very high, not others antigen, again, due to the same region. Since others antigen, there is no spike protein and antibody binding. So we don't see those type of enhancement. So this sensitivity is due to the antibody, nothing to do with nanoparticle, but this antibody attached to the nanoparticle. So since this antibody help for the selectivity, so we got highly selective in case of COVID-19 antigen using this type of surface Raman spectroscopy study. Similarly, we did the virus particle, and you can see that we can even detect 10 virus particle per ml. And that's a very, very highly sensitive technique. Raman spectroscopy can be used, even detection of 10 virus particle per ml for the detection of SARS-CoV-2 virus. So this is, I'm just showing you how we are using all different technique. And then the always question comes, there's a lot of different virus. You all know dengue, West Nile, coronavirus, rotavirus. Rotavirus is very common in India too. And dengue virus, West Nile virus is the mosquito-based virus. We all know often people die and become sick in the dengue virus. So the question is, can I separate those viruses by using Raman spectroscopy? That's a real challenge in the science. So we did a lot of work. We have several papers on that, and you can see clearly that Raman spectroscopy can be used for separating all different type of virus. I just gave you 4 viruses. Dengue and West Nile come from the mosquito virus. Coronavirus, we all know now. And rotavirus is the virus always give you food poisoning and so on from the rotavirus. Very common in India too. Diarrhea and all this disease come from the rotavirus. So I'm just showing you, really Raman spectroscopy can be used as a fingerprint for separation those 4 different viruses. Now let me give you another one technique also. We have derived that how to use nanoparticle based surface energy transfer. So this is a little bit different technique. I'm not going again more details. We published in Journal of Field Chemistry later in 2021. So in this case, we use a dye with aptamer. This is aptamer. Aptamer is a DNA or RNA which have been used as a bioconjugate molecule for detection of virus, bacteria, cancer, and so on. And last few minutes, I talk about antibody. Antibody is a protein. So there's a difference. Aptamer is a DNA or RNA, and antibody is a protein. So this aptamer we have choose, which is highly selective for binding with the spike protein. So that is the aptamer we have used. One side we have used thiol group, another side we have to dye. So that through the thiol group, I can bind this aptamer in the nanostar or nanoparticle, and other side you have a Raman probe or rhodamine-60 dye, which give you the Raman signal. So in the absence of protein or antigen, the aptamer go and bind to the surface of the nanoparticle, and in the presence of antigen, they cannot bind, they go straight, and then that is the way we can see the change of signal, and that's the way we have measured the amount of virus or antigen in the system. So this is, again, I'm just showing you, as you increase the number of antigen, and then you can see you have a more and more signal. And this is just surface enhanced fluorescence spectroscopy. Even you can detect here 100 femtogram per ml, which is like 10 to the power minus 15. 1 femtogram is 10 to the minus 15 gram. So you can see that how sensitive technique these are can be used for the detection of antigen or detection of virus. Similarly, we have done, can I show that this technique is highly selective for COVID-19. So we use flu virus, rotavirus, and so you can see that all different virus is mainly work for COVID-19. Again, selectivity always comes due to the aptamer we have used, which is highly selective for COVID-19. It don't bind any other virus, and that is why. Similarly, I can show you that same technique has been used for virus, and here you can again do the 10 virus per ml, and you can see that the fluorescence image, you can see the signal from the virus. So these all basically what I'm showing, that these all the technique, nanomaterial based technology we have derived, which can be used for either calorimetric sensing or Raman sensing or fluorescence sensing. Now, calorimetric sensing is much easier, much viable for the maybe can be used in the hospital, but sensitivity is much less than this fluorescence and Raman sensitivity technique. Next, we'll talk about how we are working for the inhibition of SARS-CoV-2 infection. So remember, I talked in the initial itself how this virus infects the human body. We talk about the spike protein of the virus can bind the ACE2 receptor of the human body with different cell, mainly lung cell, and that's the way this virus can go through the body. Now, so what is we all are looking for? How to block the binding between the SARS-CoV-2 spike protein ACE2 receptor. As you discussed before, the vaccine also works similar way. So what we are looking, can I make a nanomaterial and with peptides, maybe with aptamer and all the antibody, which really go and bind to the spike protein of the virus. So now virus cannot bind to the ACE2 of the human cell. So that's the way we are working on that. So one of the thing we always, as scientists, we always think, we all know, all the mortality rate is very high, like 5.4 million people died, but 42% of the infected individuals are called asymptomatic carrier. That means they have a virus, but nothing has happening for them. So the question always asks, why some of them is becoming very sick and some of them is not becoming sick at all. So one of the theory, as a scientist, we believe that maybe some of them health is so good that SARS-CoV-2 can be controlled by the human immune system. So let me give you what is the human immune system. The human has, in our body has all type of antimicrobial peptides, like couple of them, namely like LL37, HBD2, and a lot of other. I mean, I'm just giving you a couple of names. So those peptides we have in our human body, so that when the virus or bacteria come and to the body, this peptide fight against the virus or bacteria and so on. Like I gave you the example of alpha defensive human neutrophil peptides. Similarly, human beta defensive peptides, LL37 peptides. Those are the very well-known peptides which helps human to fight against the virus and bacteria. So since, as I give you example, 42% really they have a virus, but nothing happens to them. Even they don't get fever. So we believe that those peptides is working very nicely for them to fight against those viruses. So by using this assumption, what we did, can I use this peptide, bind with the nanoparticle so that I can block SARS-CoV-2? In this case, we have used the Delta variant virus. So what we did, we used those peptides, couple of the peptide, and then attach to the nanoparticle and see whether those nanoparticle, bioconjugate nanoparticle, can be used to block the SARS-CoV-2 infection. So this is one of the example we have used called graphene oxide. Graphene oxide we make from graphite. Graphite is a cold system. And this graphene oxide, again, we do a lot of chemistry there. I'm not coming more details. We make graphene quantum dots. And once we make graphene quantum dots, and then what I do, we try to use the peptides, LL37 and we talked recently, HNP1, those are the antimicrobial peptides in our body. So can I use those peptides to block the binding between this nanoparticle and the virus? So this is, I'm just showing you how you make this peptide as a nanoparticle. I'm not coming on that. And by doing this, I'm just showing you a lot of characterization that's a very, very common in the chemistry. I'm not coming more on that. So we have to do H.O.D, we have to do Raman, fluorescence, IR to make sure that whatever molecule we are thinking that has been made and so on. Again, details I'm not going on that. This is like TM image, SEM image, fluorescent image, all these things to prove that whatever we are thinking to make, we made that. And once we made that, then what do we find out whether this type of molecule can bind to the spike protein or not? So what we see in presence of spike protein, due to the binding of this peptide with the spike protein, we see the fluorescence of the graphene oxide decrease with time. So this helps us to tell you that yes, that means there is a huge amount of binding ability of this type of nanoparticle. Again, I'm not coming details on that. So by doing this, we can find out the fraction of peptide bind with this nanoparticle and so on. I'm not coming more, but this experiment tell us that yes, I can use this type of antimicrobial peptide as a nanoparticle for binding the spike, which is necessary because if they bind to the spike, then the virus cannot bind to the ACE2. So in that case, there will be no infection. So that's the way our experiment. So this is, I'm just showing you again the TM image, the SEM image. You can see in the SEM image, there's a lot of nanoparticle in the top of the surface of the virus. This is in absence of a peptides with nanoparticle, graphene oxide. This is with graphene oxide, and you can see clearly the graphene oxide is on the top of the virus. And since top of the virus, that means now spike is not empty to bind to the SE2 of the human surface. So this is, I'm just showing you a lot of different experiments we have done to prove that. Now this is, you can see the fluorescence image. In the fluorescence image, you can see clearly how we can see that that when there is no graphene oxide with peptides, we can see the fluorescence from the virus because we have a GIP protein we have tagged with the virus. But when you use the graphene oxide with peptides, you can see no virus is present. That means this virus cannot bind to the cell. So clearly you can see in the D and G, when you don't have any graphene oxide with peptides, the virus bind to the cell. So you can see the fluorescence from the cell. But in this case, we don't see fluorescence from the cell because virus cannot bind to the cell. So this experiment clearly shows that we can use this type of experiment to see that whether virus can bind or not, and which clearly shows that in presence of LL37 and HNP1 peptides attached to nanoparticle, in this case graphene oxide, they cannot bind. They can bind to the spike protein. As a result, those virus cannot bind to the cell. So this clearly says that we can use that for inhibition of the virus. So this is, again, we have done a lot of ACM images to show that what is going on. But we find out that this type of peptides not only bind to the spike protein, it also damages the surface of the virus. So this is clearly shows that we can see there is a hole in the surface of the virus and destroy the membrane of the virus or lipid membrane of the virus and so on. Then we find the percentage inhibition and so on. So this experiment clearly shows that LL37 and HPO1 conjugated GQDs, graphene quantum dots, can be used for the 100% inhibition of coronavirus in human body. So in conclusion, so we have developed bioconjugated nanomaterial for the detection and inhibition of COVID-19. Thank you for your kind attention. Any questions? So this is now open for questions. Any questions?
Thank you so much, sir. Thanks for your valuable words. We are really humbled for your valuable talk. It was really amazing. Thanks a lot for your valuable informative speech.
Thank you.
Sir, there is a question from the audiences.
Yes.
I'm just showing the question on the screen.
Hmm.
So the question says, in simple UG lab, how can we identify nanoparticles forming in solution?
So, as you say that in case of gold nanoparticle, the best way to see the color change, when you start making the gold nanoparticle, you start with gold chloride, which is yellow color. And when you heat with the citric acid and other stuff, you can see after a certain time it becomes the pink color, and that tell you clearly that you have made the gold nanoparticle. So you can see the clearly class change when you make the gold nanoparticle from the gold chloride, because gold chloride is yellow and this is pink. So that's how we all make it before doing any experiment. So we make sure that we have made the gold nanoparticle.
Thank you, sir. Thank you for your valuable time that you have shared, and the interaction was quite nice. Thank you so much, sir.
Thank you.
Now, I would like to welcome the second speaker of today's session, Professor Amitabha Das, Principal Scientist, CSIR, Indian Institute for Chemical Technology, Hyderabad, India. But before this, let me introduce Sir to the audiences. Dr. Amitava Das is working as principal scientist at CSIR Indian Institute of Chemical Technology, Ministry of Science and Technology, Government of India, and associate professor with the Academy of Scientific and Innovative Research, India. He has completed his PhD from CSIR Central Drug Research Institute, India, and postdoctoral research from Baylor College of Medicine, Houston, TX, and Mayo Clinic, Rochester, MN, USA. He moved as an assistant professor in the Regenerative Medicines Division Department of Medicine and held joint faculty position at Biochemistry Division Department of Basic Sciences, Loma Linda University, CA, USA, before returning back to India at 2011. Presently, the research focus of his lab is basic stem cell biology and regenerative medicines and development of novel translational therapeutics against cancer relapse or recurrence and liver diseases. He is funded by CSIR and DBT India. He has published more than 50 research papers in reputed peer reviewed scientific journals and three book chapters, and is the inventor of a granted US patent and Indian patent. He has been serving as an assistant editor in International Journal of Surgery, Elsewhere publication. He has guided 7 PhD theses and 20 post-graduation theses, while 7 PhD students are presently pursuing their doctoral work under his able guidance. Alumni of his laboratory are presently working as postdoctoral fellows in reputed laboratories in USA, other academic institutions, as well as in the pharmaceutical and biotech industries. Today, Sir will be saying about to be or not to be transcription factors as targets of cancer therapeutics. Please, sir, platform is all yours.
Uh, Thank you. Good morning to one and all. Am I audible?
Yes, sir, you are audible.
And if I share my screen, please let me know if it is visible. Is it visible?
Yes, sir, it's visible.
Thank you very much, Dr. Bhowmik, and um, a very good morning to one and all present today in the forum and who will be listening to the talk. Once again, I thank for this nice introduction about me, and to all the students over there, and of course the faculties who are working in the field of science and trying to study and be a scientist in for future. Let me start my today's presentation with the famous proverb by Shakespeare in Hamlet: to be or not to be is the question. Indeed, if it is in a scientific world, it is a question for the transcription factors as a target for cancer therapeutics. The focus of my lab, as I said, is of course stem cell biology, where we study the basic biology and the tissue engineering for regenerative therapies. Not only limited to this, but my lab also focuses on the cancer stem cells to understand a molecular signature, to evaluate, to identify a molecular signature in the specific area of breast cancer stem cells, to understand its role in epithelial to mesenchymal transition, which in short, in today's talk, I will be calling it as EMT, and the role of chemoresistance in these breast cancer stem cells that imparts metastasis of this disease and recurrence and relapse of the disease. So to begin with, as I said, my lab focuses on the breast cancer. If I have to mention about this, is one of the most predominant types of cancer in females, but not limited to females. There are also unique cases of breast cancers being diagnosed in males across the worldwide, which has been mostly mentioned as it is the second most common cause of disease mortality and morbidity in women. If we have to look into the role of these breast cancer, not only in across the world, but let us focus on what is the status of it in India per se, because we are concerned about this disease as we have seen in the clinic, that is one of the most number one kind of disease cancer disease which is being diagnosed in female in India too. If we look into the statistics of it, the epidemiology of its occurrence, more than 25.8 per 100,000 women are diagnosed with breast cancer, of which, unfortunately, close to 49.2%, that is close to 50% of them undergo mortality. And that is 12.7 per 100,000 women. That's quite a lot of number of diseases in the high prevalence of the disease as well as the mortality rate. So, and it is not limited to a jurisdiction wise a particular type of the urban or the rural nature of the disease, which has been always been found that the rural mortality to incidence ratio was found to be more in the rural registries but than in the urban registries. That can be attributed to the fact that the availability of the high end medication facilities which is available in the urban areas, we get more of the cured patients in the urban areas rather than the rural areas. So the cause of these disease and the it becomes more pertinent for us to understand the nature of the disease, to identify more new therapeutics to combat this disease. Not only natural products with anti-proliferative cytotoxic properties against the specific cancer cells are being continuously explored, but there are also designed synthesis of small molecules against specific molecular targets, which today's talk will actually elaborate and make you understand how do we identify molecular targets and how the design synthesis of small molecules are being performed. But if we look into the clinic, it is not that if we get to hear there are so many cancer survivors, breast cancer survivors. That is because of the fact that the recent advancement in the chemotherapeutic, radiotherapy, and various other modes of cancer development, therapeutics that has been developed in the field of cancer research that led to the successful treatment of breast cancer. Nevertheless, this successful cured breast cancer patients often undergo in the relapse or the recurrence of the disease. And that percentage of patients are also very high. Almost 40% of the patients are suffer. They end up in the relapse and recurrence. So the question is, why do these patients relapse and recur in a certain amount of patients? That is because of a small population of the cell of the in the tumor populations that are resistant to these chemotherapeutics or the radiotherapy, and we call them as a cancer stem cell. The reason, or the cancer initiating cells, the reason, because these cells has been shown to possess similar properties of a stemless phenotype like other naturally occurring stem cells. But these the question always remains, why and how do these cancer stem cells evade the chemotherapeutics or the radiotherapy? So that is what occurs because of a phenomena, what I introduced today in my explaining the focus area of my research, is that epithelial to mesenchymal transition. This will be more clear in the next slide, where I'll be explaining you what are these. This EMT, in short, that we call, is a naturally occurring phenomena that occurs during your embryogenesis or the organ development or regeneration of any damaged tissues. But out of the three different types of EMT, Type 3 associate EMT is associated with a cancer progression and the development of cancer stem cell. As the cartoon over here shows the diagram, how normal epithelial cells loses its basement membrane and undergoes transition and forms a mesenchymal phenotype. These are highly invasive and metastatic, and that goes for the secondary tumor generations. So the question always remains, how does a cancer cell convert into a cancer stem cell? So in the literature, there exist two different school of thoughts. One, which believes in the A part of the figure. If I can draw your attention towards here, the A part of the figure is called as a cancer stem cell model, and the B part of the figure is called as a clonal evolution model. Now, the cancer stem cell model defines that any stem cell that is present in the body or the progenitor cells that undergoes mutation and generates into cancer stem cell. And these cancer stem cells can differentiate or develop into different types of cancer cells. However, this particular model doesn't have too many takers, whereas me as well as others in the field, we believe in the other clonal evolution model, where we believe that a cancer cell within the tumor microenvironment, based on the epigenetic or the genetic events, that undergoes into the formation of cancer stem cells. And these cancer stem cells possess the self-renewal ability, and they can differentiate into multiple types of cancer epithelial cells and generate into the secondary tumors. And these are highly resistant to chemotherapy and radiotherapy, and they are highly migratory potential and invasive in nature, and this leads to the metastasis of the disease. That is what is the next question: how does this happen? Now, if we understand, now it becomes more and more pertinent for us to look into what defines these cancer stem cells, especially the breast cancer stem cells. Now, different types of cancer tumors that occurs in the body. If it is a breast tumor, there is a breast cancer stem cells. If there are liver tumor, there are hepatic cancer stem cells. So different types of tumors that has got different types of cancer stem cells present in the tumor tissues. Now, one needs to identify with certain markers or the factors that will give us the phenotype and specific to the type of the tumor tissues. So something one called the CD factor, or the cluster of differentiation, where we have shown that CD24, which is one of the surface marker, which is very low in expression or null or it does not express at all on the surface of the cancer stem cell, breast cancer stem cells, but there is a higher expression of CD44. surface markers. Now, we and others in the field have all extensively utilized this CD24 negative, CD44 positive breast cancer stem cell populations and identified various different molecules that can be targeted as a chemotherapeutic drugs. Now, in the next subsequent couple of slides, where I will be actually explaining to you some of the studies which we have performed in collaboration with different scientists across the country as well as outside. But whenever we talk about certain biomarker as a as a as a biomarker for a particular disease, we always try to identify whether or not it is clinically relevant. So to understand the clinical relevance of the expression of CD44 in human breast cancer patients, I collaborated with my clinical collaborators from Mahatma Gandhi Institute of Medical Sciences, Wardha, where we got the tumor tissues from the patient samples, and we identified the expression levels of various different markers like CD44, CD24, another stem cell marker which we call CD133, Vimentin, and E-caterin. Now, we have observed in this particular figure A, where there are these individual dots are actually the patient samples. So we have observed various different types of patients with higher and lower expression of these markers, CD44, CD24, CD133, and Vimentin. So we wanted to question ourselves. We know from the clinical studies point of view that there are different stages of breast cancer, and if I can explain to you in this next particular figure, where we are showing that there are 4 different stages of the 0 to 4, that is 5 different stages of breast cancer. If you look into the stage 0, that you actually identify initially there are abnormal cells which are lining the ductal tissues of the breast, and they are abnormally growing faster. That we call as a stage 0. That is not so spread tissue within the mammary tissues itself. The tumor cells are present, but however the early stages and the stage 1 and stage 2 are localized within the tumor tissues, and then stage 3 types of cells are actually regionally spread, that are spread across the different types of other types of cells across in the mammary tissue, and that leads to the generation of more and more in aggressive cancers. But if you look into the stage 4, which is the distant spread, that it starts localizing from the mammary tissue to the different other types of localized areas within the patient body. And if I can draw your attention to the lower part of this particular figure, if you see the percent survival rate of the patients with the increasing stages, the rate of survival rate decreases remarkably high. So what we see that with 100% curable patient at stage 0 leads to only 16% survives when patients are diagnosed with stage 4 disease. So we wanted to actually identify our patient samples, what we have done, what we have performed with the help of a pathologist from MGIMS. Like we could distinguish between 2 different stages of this tissue cancer from these patient samples. Those were stage 2 and stage 3, and we evaluated the expression levels of these markers: CD44, 24, 133, Vimentin, and Caterin. So if I can draw your attention to the figure B part of this figure, where we have seen the significant increase in higher stage 3 of expression of CD44, CD133, and Vimentin, which is a mesenchymal marker of the cells, but lower expressions of or insignificant difference in expressions of CD24 as well as E-caterin. So we wanted to find again what is the clinical relevance of CD44, and we observed from the TCGA database that a higher expression of CD44 leads to lower overall survival of the patients. So this tells us that CD44 expression is relatively elevated in the stage 3 of the breast cancer patients, and so we evaluated the role of these in subsequent studies. With this, I would like to conclude my presentation and request you to give me your opportunity to ask questions.
we are having some network issues, so I'll just request every participants to be together. Sorry for the inconvenience. I just request all of the participants to stay for the couple of minutes. I think we are having some network issues. So I just request each and every participants to be there. Sir is joining. Yeah,
Um,
yeah, sir
I'm,
has already joined.
I'm very sorry for this. I'm not aware why did this happen. So I'll try to share back and let me know from which slide you could hear. I can start from there. Could you guys hear me from up to this slide?
Yeah, yes, sir. Yes, sir.
So from here I'll start.
Yes, sir.
Okay. Well, so sorry for this interruption, but if I can again remind you of that, there are various different types of breast cancer that are defined based on the hormonal receptor based dependent, like estrogen receptor ER positive, progesterone receptor PR positive, or human epidermal growth factor receptor, which is HER2 positive. And among these different types of receptors, where the based classification of breast cancer, there are drugs available such as the types of breast cancer which is triple positive, that is called ER/PR HER2 positive, called luminal breast cancers. We have tamoxifen, which is works effectively against this. Similarly, there are a type of breast cancer where there is a HER2 positive only, but ER/PR negative. And antibody based drugs, like there are various other types of drugs also, including Herceptin, which is effective against this. However, the TNBCs, as the name suggests, triple negative breast cancer, which are negative for all the three hormonal receptors, ER negative, PR negative, and HER2 negative, but there are very limited amount of drug therapies which are available. So it becomes more pertinent for us to identify molecules or identify therapeutics which can be effectively targeting these TNBCs. And to actually tell you, these TNBCs are the most aggressive types of breast cancer, and this aggressiveness depends upon its metastatic properties and chemoresistant and radio resistant. So we wanted to actually identify, depending upon expression of these CD44 and CD24 in different types of cancers, breast cancer cells. And we observed that both HER2 as well as the triple negative breast cancers expresses significantly high upregulated expression of CD44 and lower expressions of CD24, whereas the luminal types expresses more of a CD24, higher expression of CD24, but less of CD44. So with these particular information of data, we wanted to work very much in detail, which about identifying the natural analog of chrysin. This work I have performed with my collaborator from your city, Dr. Shudhan Debnath. I actually designed certain molecules like of chrysin. Now, chrysin is a known chemotherapeutic agent, but has got a lot of limitations. So it has a poor therapeutic potential because of poor absorption and metabolism and fast systemic elimination. To avoid these limitations, what my collaborator Dr. Debnath has done is he designed some synthetic analogs of these molecules against EGFR. Why EGFR? Because if I can draw your attention towards the figure A and figure B, both at a RNA and the protein level, we could see that these triple negative breast cancer called as MDMB231 had higher expression levels of EGFR, which is one of the receptor tyrosine kinase. So with my information of these data sets, what Dr. Debnath has done, he designed certain synthetic analogs of chrysin and to target this EGFR. And he designed with this molecule as the parent molecule chrysin. Based on the parent molecule, the figure D shows that the design analogs of it, synthetic analogs of these one which has got a more affinity towards binding, and which with his molecular binding docking studies, he had shown that indeed CHM09, that is the analog of the chrysin molecule, parent chrysin molecule, binds effectively to this particular EGFR molecule. With these in silico informations, where he has shown that there is an enhanced binding of CHM09 and EGFR, we wanted to substitute his information with our knowledge of binding. So what we did is we performed a cellular thermal shift assay, wherein we try to identify whether or not the small molecule in question binds to the protein in nature, protein of our molecule. So we could show that at a higher concentration, CHM09 exhibited a higher binding affinity towards EGFR as compared to its standard inhibitors. If you can see that at 50 degrees centigrade, where we could see still there was a binding of CHM09 to EGFR as compared to the right side's PD153035 or AG1478, which are the sigma molecules, which are the standard EGFR inhibitors. As compared to them, we had got a significant or markedly higher binding affinity of CHM09 towards EGFR. So with this information, we have worked out various different studies looking into, but our question always remains that whether or not it will be effective against breast cancer stem cells. So we utilize the isolation systems, which is one of the most standardized one we performed in our lab, is the magnetic activated cell sorting system, and we have performed like CD24 negative, CD44 positive populations, as it is seen here with 9.3 per plus minus 1.6%, which is very low, less percent of cells from the TNBC cell types we can isolate out these ones. Utilizing these, we first of all characterize them, whether or not they are expressing utilizing confocal microscopy or the RNA level, various different expression markers, and at the protein level, whether or not to check the purity of these populations, and finally to show that these cells are also ALDH positive, aldehyde dehydrogenase positive, which is one of the most characteristic feature of cancer stem cell. So with these information of characterization, isolation and characterization of the breast cancer stem cells from the triple negative breast cancer cells, we performed various different expression studies, where we can, if I can show you in a small model base, that we have utilized CHM09, which inhibits the EGF binding to the EGFR, that in turn regulates which inhibits the ERK, AKT, JAK-STAT activation. We know that with these inhibition of this activation, that decreases the proliferation and migration of the triple negative breast cancers, that leads to decrease in the mammosphere formation, that is in vitro tumorigenesis, as well as trilineage, mesenchymal trilineage. As I said, the cells within these cancer stem cells are more of mesenchymal phenotype, so it decreases the standard mesenchymal trilineage differentiation capability, and then it converts this mesenchymal cells more towards epithelial. That means it undergoes MET and leads to the chemotherapeutic responses. And this particular work was published by us a couple of years back in the Feb's journal, where we have shown that if we inhibit epidermal growth factor receptor signaling by a specific molecule like CHM09, it potentiates the mesenchymal to epithelial. That is, it reverses the EMT back to the MET, and thereby increases the responsiveness of the to chemotherapeutic drugs such as doxorubicin. So not only this particular work, but there are other studies also where we have identified, and in the literature it shows that glutathione S transferase among various different isoforms of it, omega-1, enriches in metastatic breast cancers. And how this happens is that whenever these particular chemotherapies are addressed to these cells, when these cells induces hypoxia-dependent GST01 expression, and that leads to aggressiveness of these breast cancer stem cells, that leads to its metastasis. So we wanted to evaluate whether or not that happens in these aggressive breast cancer cells, and we identified that the MTAP231 cells, among the various different types of chemotherapeutics, if they are treated to these cells, there is an increase in the expression of GST01 at a protein level. So we wanted to question that how come tamoxifen is inducing. If we can draw your attention to this, the first MTAP31, this particular cursor where it shows with treatment of tamoxifen, there is an increase in GST01. Now, tamoxifen is known to be working through the ER-PR receptors, PR receptors, progesterone receptors. But these MDMA231 lacks ER-PR receptors. So we questioned, how does this particular drug induces the expression of these? So there must be certain ER-PR independent effect onto this on these aggressive breast cancer cells. So this becomes more, we wanted to identify efficacious small molecules scaffolds that can target GST01. To this, I collaborated with one of my collaborators from Maharashtra who designed and synthesized sulfonamide chalcone molecules. Now, if we have performed the biological activity of this, like the growth inhibition, 50% growth inhibition, total growth inhibition, or the lethal concentration 50 of these using various different types of triple negative breast cancers, and compared them to the control cells, HEK, human embryonic kidney cells. And we identified one of its analog named as S2E, which is selectively more cytotoxic against triple negative breast cancers as compared to the control cells. So we wanted to identify whether or not this particular analog S2E has got a binding affinity towards the GST01 molecular target. And where I again went to my collaborator, Dr. Debnath from Tripura, MBB College, Tripura. Earlier, he was at MBB College, and he performed this molecular binding affinity studies, and he showed that indeed S2E molecule has got relatively higher binding affinity towards GST01. And to support his findings, we again performed the CETSA cellular CETSA analysis, and we've identified, yes, indeed, S2E has a binding affinity towards, it is protecting the GST01 from at a higher temperatures as compared to the control. So with these informations, and of course with various different other parameters, what we have worked out, I will not go very much detail about it, but I'll explain to you what actually happens in a chemotherapy, in presence of a chemotherapeutic in these breast cancer stem cells that activates various different types of signaling, like SRC-AKT STAT3 signaling or ERK signaling, and it decreases the P38 signaling and GNK signaling, GNK dependent apoptosis signaling. So that leads to more and more proliferation of these breast cancer stem cells, and leads to migration of the cells, and thereby leading to metastasis of these particular cells towards different sites. But our work, we have shown that if we inhibit GST01 with S2E, it is actually inhibiting the JAK-STAT, the JNK mitochondrial apoptotic signaling, and thereby inducing the cells more towards apoptosis. So this work again we had published a couple of years back in Feb's journal, where we have shown that glutathione S transferase omega 1 inhibition activates the JNK mediated apoptosis response in the breast cancer stem cells. So if you remember, I have earlier told about the CD44. So we always had this question: what is the downstream signaling of CD44? And because all these cancer stem cells, breast cancer stem cells, they express higher levels of CD44. So to identify the downstream target of molecular targets of CD44, we performed RT2 profiler PCR array. Now, with these cells, what we do that hyaluronic acid is one of the ligand for CD44, and another inhibitor of hyaluronic synthase called 4-methylambiliferone or 4-MU is an inhibitor for this particular signaling. So among the various different types of various molecular targets that we identified, I would like to draw your attention towards two of them, which is one of them is a metabolic target called the lipoprotein lipase, LPL in short, and which is shown to be 16-fold higher in expression in the breast cancer stem cells. Whereas another target, which is again EMT target, called SNAI3, which is again another isoforms of SNAI, with that there is a transcription factor has been shown to be markedly lower in expression of these particular. So we wanted to validate our in vitro in silico analysis, as is shown in figure E and F, showing that with in presence of hyaluronic acid, LPL increases, that is perturbed in presence of 4-MU. And not only this, the hyaluronic acid led to decrease in expression of SNAI3, but with inhibition of 4-MU, SNI3 expression was higher. So this is not only that, we have also done at a molecular level, where we have silenced using CD44 silencing, and we could see the expression down regulation of LPL and up regulation of SNI3. So with these information with us, what we wanted to say, of course, I would like to also add that when we were working on these hyaluronic acid pathway in CD44 expressing breast cancer stem cells, we identified in the a significant signaling pathway, which with the paucity of time I won't be able to show you, but we identified another particular transcription, another signaling molecule called STAT3. Now, STAT3 upon activation, the phospho-STAT3 translocates within the nucleus and acts as a transcription factor. So we wanted to identify what regulates the LPL. This being a hardcore biology, stem cell biology lab, and we are more interested on transcriptional modulation of various different molecular targets. We identified the presence of STAT3 binding sites using in silico analysis on the LPL promoter, and we identified 3 putative binding sites of STAT3, and therefore we generated a luciferase vector, and we performed luciferase active. First, we identified various different binding sites of these using chip analysis, and we observed that particular BS1 binding site had shown to be in presence of hyaluronic acid had higher STAT3 binding at this, called the chromatin immunity precipitation, that was supported by the luciferase activity, and which showed that indeed the binding site 1 was more essential for LPL promoter activity. Interestingly, we observed there were 2 putative binding sites of SNAI3, which is again a transcription factor, onto the LPL promoter, and we observed using chip analysis, the chromatin immunity precipitation analysis, that again the binding site 1 of this SNAIL3 was observed to be having more significant binding of SNAIL3 onto the promoter. That was also supported by the decreased promoter activity in presence of hyaluronic acid. So this shows that both SNAI3, there is an yin-yang regulation of phospho-STAT3 and SNAI3 on the LPL promotion. Why LPL promoter activity? Why would we say that? Because STAT3 positively regulates LPL activity, LPL promoter activity, whereas SNAI3 negatively regulates the LPL promoter activity. So with these information, what we wanted to identify whether or not it works in an in vivo situation. So we generated orthotopic xenograft murine model, and we transplanted these human cells onto the mice, and we observed that there was a significant increase in the percent of tumor incidence, and the tumor size was higher in the group which were xenotransplanted with breast cancer stem cells. Silencing of these breast cancer stem cells with CD44 silencing has abruptly lowered the tumor size as well as the tumor incidence also. Not only that, we generated another model where we initially generated the model with the breast cancer stem cells, and after the tumor size was grown, we intratumorally injected a pharmacological inhibitor of lipoprotein lipase called THL. Now, with these THL, we could see that it significantly decreased the tumor size comparative to the control cancer cells. So not only that, the tumor weight was higher with cancer stem cells, as well as various histological analysis proved that the cells there are more proliferating cells onto the tumor, onto the xenotransplanted tumor, xenografted tumor with the breast cancer stem cells. So not only that, we wanted to identify our targets like the SNAI3 or the LPL. If I can draw your attention towards these confocal images, these confocal images are from the tumor tissues, which we section the tumor tissues, and we stain them with various different antibodies, and we have observed that with in the tumor tissues which are xenotransplanted with cancer stem cells, they were showing increased expression of LPL and decreased or null expression of SNAI3. But with the help of CD40, the cells which were the tumor tissue which were grown with by xenotransplanting cells, stable cells with stable silencing of CD44, could show that there was increased SNAI3 but decreased LPL. So this tells us that LPL and SNI3 are two important markers which are required for the murine tumor. So to corroborate these with the human situations, we again collaborated with our clinical partners, and we from the tumor tissue samples what they provided us, we observed that LPL at a stage 3 showed significantly higher expression of LPL in that stage 3 breast tumor tissues as compared to stage 2. Similarly, there was significantly decreased expression of SNAI3 in the stage 3 as compared to stage 2. So this tells us that LPL and SNAI3 works opposite to each other, but they are important for the tumor tissues. For the LPL is to be important for the tumor tissue. So again, going back to the TCGA database, we evaluated that if there are patients with high LPL expression actually has a lower overall survival. So this again tells us that the targets, what we have molecular targets that we identified from our microarray datasets and validation through in vitro validation as well as in vivo, and has correlates well with the clinical samples, clinical database. And we have successfully published this particular study this year, this year itself in 2021 in BBA molecular basis of disease. With these studies, as I showed, like there are various different receptor tyrosine kinases like EGFR. They're not only limited to EGFR, but there are various other receptor tyrosine kinases which has shown to have like TGF beta, PDGFR, FAC. There are various different receptor tyrosine kinases which are shown are involved in regulation of the cell proliferation, survival, differentiation, and migration. And these dysregulation of these receptor tyrosine kinases are often associated with various different types of cancers. Now, we have also observed that there are EMT transcription factors, like which are classified into three major families, like basic helix, loop helix family, called twist1 and twist2, or the zinc finger family like Z1 and Z2, as well as the myodi family, which are the snail, slug, or smug, which is SNAI1, SNAI2, and SNAI3. Which are used as EMT biomarkers, also regulates the receptor tyrosine kinases. So we hypothesized if other receptor tyrosine kinases can be regulated by these transcription factors, and before that, we wanted to find the clinical relevance of this particular transcription factors, like twist1. Twist1 is transcription factor has been shown that there is a high expression of twist1 was associated with overall low survival as well as relapse-free survival in breast cancer patients. So with these target like EMT transcription factor being having high clinical relevance, we generated a stable breast cancer stem cell with a stable overexpression and or silencing of twist1, and then evaluated the expression of these ones and its downstream to identify its downstream targets. So in search of these downstream targets as well as its relevance, we first overexpressed this twist1, and we observed that overexpression of twist1 led to increased chemotactic activity as well as in vitro tumorigenic potential in the breast cancer stem cells as compared to the breast cancer cells. Now, silencing of these twist1 in the breast cancer stem cells decreases its chemotactic and in vitro tumorigenicity. Not only this, we have also performed molecular analysis of it, and we observed that twist1 overexpression led to activation of PDGFR beta in the sorted breast cancer stem cells, and that was mitigated by twist1 silencing. So we hypothesized that indeed, if twist1 overexpression is activating PDGFR beta, is it being regulated, transcription is regulated by PDGFR beta, by twist1. PDGFR beta is transcription regulated by twist1. To prove this, we again identified whether or not PDGFR beta will be it does have any clinical relevance in breast tumors, and we observed that indeed high expression of PDGFR beta was associated with not only overall survival but also disease-free survival of breast cancer patients. So these tells us that indeed both twist1 and PDGFR beta are clinically relevant biomarkers, and that can be evaluated for further mechanistic studies. So we have performed both analysis of twist1 and PDGFR independently, but now we wanted to correlate this, whether or not twist1 is correlated with PDGFR beta in breast cancer stem cells. And in breast cancer samples in clinically, we observed that higher the expression of twist1, higher is the PDGFR beta expression. So it is positively correlating in breast cancer patients. So therefore, we wanted to hypothesize that maybe twist1 being a transcription factor, in the C part of the figure, if I can draw your attention, twist1 being a transcription factor enters into the nucleus and binds to the particular site called the E-box elements on the promoter region of the PDGFR beta, that in turn activates the PDGFR beta expression, which when gets activated onto the translocates onto the cell membrane, and upon activation, it activates downstream effectors like FAK, focal adhesion kinase, or the SRC, and that leads to metastasis and invasion, as well as cancer cell survival or relapse or recurrence of the tissue. So we performed extensive transcriptional biology experiments where I will be describing it, but let me just tell you briefly that when we evaluated the promoter region of these numbers, what it signifies are the promoter sequences of the PDGFR beta, and we observed that there were 4 putative twist1 binding sites onto the promoter of the PDGFR beta. This tells us that yes, transcriptionally, we have also worked extensively showing that there is a transcriptional regulation of twist1 on PDGFR beta, but I will not show you the data about over it, which is already published. One can look into it if they are interested. That yes, indeed, PDGFR beta is the transcriptional downstream target of twist1. And so to corroborate our in vitro findings to the in vivo, we again generated a nude mice xenografted, orthotopic xenografted. Why we call it as an orthotopic xenograft? Because orthotopic means breast cancer cells being injected into the mammary fat pad of the mice. Since it is a xenograft, because human cells are transplanted onto the mice, we call it as an orthotopic xenograft. In the nude mice, which is lacking the it lacks the immune system to reject the foreign cells. Therefore, the tumor tissues grows into those cells. And we have transplanted various different types of stable breast cancer cells and cancer stem cells with overexpression of PDGFR beta, and cancer stem cells with breast cancer stem cells with silencing of PDGFR beta, along with the respective controls. And it is shown that it's the morphological assessment of breast tumors. The right side one, the right one with the arrow, blue arrow, shows a markedly larger size tumor or xenotransplanted into the nude mice that generates because of the overexpression of PDGFR beta in the cancer stem cell populations. And that cancer stem cells with silencing of PDGFR beta led to a markedly lower size or nil cancer tumor development. This was again after histological immunohistochemical analysis, we showed that indeed PDGFR beta is essential for maintaining the stemness property of the breast cancer stem cells, as it's shown by the co-localization of transplanted human gene transplanted PDGFR beta with human CD44 expression in the group which were xenotransplanted with PDGFR cancer stem cells, breast cancer stem cells overexpressing PDGFR beta. That was mitigated with PDGFR beta silencing group. Not only that, with these enforced expression of PDGFR beta drove the cells towards breast cancer metastasis to lung and the liver tissues. And we could see that there were increased expression, similar co-localization of PDGFR beta, human-specific PDGFR beta and CD44 onto the lung and the liver tissues of the group which were xenotransplanted with breast cancer stem cells overexpressing PDGFR beta. This tells us that indeed these targets are very important, as the working model shows that in the breast cancer stem cells, twist1 is relatively higher in expression. That translocates into the nucleus in the left panel of the figure, translocates into the nucleus, binds onto the E-box elements that leads to the PDGFR beta promoter activity increases that generates PDGFR beta mRNA and the PDGFR beta protein. That active protein gets activated on the breast cancer stem cells upon by phosphorylation, that in turn activates FAC, SRC, and that leads to the migration and proliferation of these breast cancer cells and breast cancer tumorigenesis. But we could inhibit it using PDGFR beta shRNA. That is what it inhibits. This shRNA or siRNAs, shRNAs, what it does, it cleaves off the mRNA, active PDGFR beta mRNA. Therefore, there is a PDGFR beta protein is less, that it does not, it inhibits, it does not have the active protein, and the whole signaling is inhibited, as well as therefore the breast cancer tumorigenesis is inhibited. So this work of ours has been recently published this year in again BBA, molecular basis of disease. With these, one not only EMT transcription factor, I hope I have some time.
Yes, sir.
Okay, fine. So I'll wrap up the last part of my talk about not only twist1. There are other transcription factors too, which are present on the breast cancer stem cells, like snail1, snail2, zeb1, zeb2, and we observed that in the TNBCs, there was a significant upregulation of expression of the snail1, which is not only at mRNA but also at the protein level. So we hypothesized that the snail1 EMT transcription regulator can modulate the EMT associated differentially expressed genes in the breast cancer stem cells that can lead to tumorigenesis and metastasis. In these one, my lab basically focuses on identifying molecular targets that can be a druggable target. So in search of this, what we did, we identified another transcription factor which is also expressed higher in the triple negative breast cancers that can be targeted to identify its downstream effector molecule. So what we did, we performed an in silico evaluation of the microarray analysis, and there we identified, by curating the data, we identified various different expressions of genes which were significantly higher in expression. Among them, when we classified these particular differentially expressed genes, we observed that the one with a biological phenotype of epithelial to mesenchymal transition showed higher percentage of genes present in this microarray. So we performed in silico analysis, where we identified its binding various binding potential of these particular identified targets to each other to identify, and we evaluated these expression of these particular in silico identified targets using the in vitro validation process. But before that, what we wanted to identify the targets what we identified, that belong to cell adhesion or extracellular matrix proteins or the cytoskeleton motility and motility factors or the growth factor surface receptors. What are those transcription factors that can have a binding sites onto the on these targets? So these targets, differentially expressed genes, had shown that there were relatively more number of snail binding site, or SNAI1. In short, we call it as the snail binding sites were higher on these differentially expressed genes. So we wanted to with these in silico, we performed in vitro validation of these in silico analysis, and we could see, what we first generated is that we generated a stable luminal cell wherein we overexpress snail. Now, luminal, if I can draw your attention, if you remember, initially I explained to you that luminal types are the one which are ER, PR, and HER2 positives, like MCF7 cells, and these cells express very less or negligible level of snail. So therefore, we wanted to see if we can overexpress snail on these luminal cells. Do they behave similar to the triple negative breast cancers? And indeed, we observed that in these particular ones, the second and the third rows, which are this is the T47D. The third row is first is the MCF10A, which is a naturally which is a control epithelial mammary epithelial cells. Then T47D, which is again a luminal cell type, which again there is another one which is MCF7 which is again a luminal type. And this next row is that this MCF7 is the one which overexpressing the control vector, whereas the next, when we overexpress snail onto the MCF7, that behaves similar to the TN basis in expression of various different differentially expressed genes that we identified from the in silico analysis. So with this validation of in vitro validation of the in silico analysis, what we question, if there is we observed that from in silico analysis that there is a promoter binding site of snail1 onto these differentially expressed genes. We performed an extensive landscaping of these promoters using promoter reporter activity assays, and we identified that from the various different sites which are present, and we generated deletion mutants of these promoter sites, and we identified the promoter regulation pattern of these by snail. And with these ones, I will not go detail about it. This is a very extensive study which my student has performed very recently, and not only luciferase assays to show the promoter activity, but we have also done the chip analysis, the chromatin immunoprecipitation analysis, to identify among the various different binding sites of snail the e-boxes, to which particular e-box does snail bind for transcriptionally upregulating these differentially expressed genes. So with these data sets, what we have also identified is downstream effectors, not only the upstream transcription regulators. One among them was the MMPs. So we utilized MMP inhibitor GM6001 or elomostat. We call it an elomostat. I want to share that this is a clinically relevant molecule which is there in the clinical trials for different diseases. For eye disease, it is being under clinical trials right now. But we utilize this elomostat, and we observe that if we inhibit MMPs using elomostat, this effectively mitigates the invasiveness as well as migration, as well as tumorigenesis potential of the breast cancer stem cells. So not only this particular work, which was published recently in Cellular Signaling by my student, but also I would like to draw your attention that there are not only these differentially expressed, these many differential, there are many other transcript genes which we have identified using in silico analysis, where we identified by one of my MTech postgraduate student who has done this particular in silico analysis, Rohit. He showed that there are top 20 genes which are most overrepresented fold factor in the EMT inducing transcription factor binding filaments. Like not only these genes, EMT transcription factors, twist1, ZEB1, snail1 belongs to 3 different families of transcription factors, like hand family for hand family for twist1, Myodi family for snail, and Zep family for ZFX, HFX. These families, they are relatively different levels of these transcription factor binding sites onto the promoter region, and thereby regulating its downstream targets. To address that, it is not that simple to understand that how the transcription factors work. Not only that, I want to also draw your attention that we evaluated more extensively using in silico parameters, wherein these transcription factors like twist1, zeb1, snail1, they themselves are also being regulated by other transcription factor binding sites, binding families. So you can understand the complexities of these transcriptional regulations by these transcription factors that has been shown to be regulating as that. Our quest was to identify the master regulators of these cancer transcription factors, master regulators. So in this one, this study, which we have recently published a book chapter on this, where we have shown that there are various different transcription factors that in turn regulate the EMT transcription factors that work as targets for these genes. For therapeutic targets. So not only that, we have performed drug interaction studies with these EMT transcription factors as well as the EMT target genes, and we observed that there are various known drugs which are either being prescribed to the patient, or several of them are not being evaluated for breast cancer, which can be utilized from these ones. So this particular study has shown that there are various different drug targets which are existing, which can be utilized as a drug repurposing for breast cancer stem cells from these information, from these knowledge of ours. So not only this, there are various, not only our studies, but there are also various other preclinical studies which are undergoing in the literature. One can find that these are being targeted against the EMT pathway. Now they can be EMT transcription factors or the EMT genes or the EMT signaling molecules that has been targeted at. These are the various, these enumerated ones in the table are the one which are there at the preclinical stage. Not only that, we have also identified that there in literature one can also see that there are several such molecules which are on different phases of clinical trials, which are undergoing different phases of clinical trials, which target these EMT genes and EMT transcription factors. So the task is really big to actually delineate and identify more novel molecules that can target EMT transcription factors as well as its EMT genes. So the question will always remain, what is more effective? Should we target the transcription factors, or should we target its downstream effectors? So one thing I would like to share with you as a scientific, from the scientific perspective point, or the scientific point of view, I as a scientist, I always look for to identify its effector molecules. Why? Because these transcription factors are not only regulating the cancer genes, but they are also important for affecting various other physiological phenomena in the human body. So if we can identify these pathways and then identify the downstream effector molecule, effector targets of these EMT transcription factors, and generate, develop in collaboration with chemists, pharmacologists, pharmacists, various different parameter, other field people, and we can generate specific molecules targeting these, we will be effectively able to answer this particular question. Can we cure cancer? And to answer this, I always say, more and more research to do. There is a lot of drugs to be developed to cure the cancer. As we always see, and we say, miles to go, things to do, and wishes to fulfill. This is, as a scientist, it is all our wish, our dream to find out a cure for the disease, which is so dreaded. So many people are suffering from that. And so therefore, we know, as a scientist, I know it very well that we have to go miles together with several of you young budding minds to along with us to find the cure for this disease. So at the end, I would like to thank for the first my funding agencies who are supporting my studies, like DBT, CSIR, various different programs in the CSIR Mayo Clinic partnership program that I had, and my collaborators, the clinical collaborators from USA, as well as from India. My collaborators, Professor Kullan Goswami from AIMS Kolkata, from AIMS Nagpur, Dr. Bhupender Mehra, and MGIMS Wardha, Dr. Nitin Gangane, and Dr. Anupama Gupta from MGIMS Wardha, and of course my chemistry molecular study docking studies partner, Dr. Shudhan Devnath from Agartala, and other collaborators who are there. And nevertheless, all these informations what I could share with you were only been possible because of my excellent team of students, my lab alumni, as well as my lab members who work effortlessly, timelessly. They keep on working and to fulfill all their dreams, as well as our dream to being successful as a scientist. So today I have talked about most part of the work is my fourth PhD student, Kanakaraju. He is presently working as a postdoc at the University of Cincinnati, USA, and Ragini, who is about to board for her postdoc venture at Northwestern University, Chicago, and USA, and Digvijay, who has submitted his thesis and waiting for his viva to occur. And nevertheless, Neha, Satya, Soumya, and Komal Kuli have worked on the regenerative therapies part of my lab. And presently, Surbi is working on the chemo-resistant, the data which I did not share with you guys. Presently, she's working on the role of how chemo-resistance occurs in breast cancer stem cells, the molecular mechanism of it. And Trisha and Shruti is working on the epigenetic regulation part of it, of the cancer. And of course, Shubho, Shilpa, and Rahul are working on the regenerative medicine part of it. So thank you very much for your patient hearing, and I would appreciate your questions. And here is my email ID. If anybody is interested, can contact me. Thank you. I'll stop sharing then.
Thank you so much, sir. It was really much informative and expressive presentation. We are really very grateful to you. Thanks for your valuable time that you have shared with us. So now some questions from the participants. I'm just showing it on the screen.
Wonderful.
So the question says, can chrysin be used as an anti-cancer drug?
It has been shown that chrysin has a limitation as an anti-cancer drug because of its low bioavailability. And to improve the bioavailability, as I discussed, my collaborator, Dr. Devnath, had actually designed it to target it through EGFR target. Now, what we have shown, and we and others have already shown in the literature, that when we target out these EGFR as an anti-EGFR molecule, it sensitizes the cells, which are aggressive cells, towards the existing chemotherapeutic. So, in a way, these molecules like chrysin can be utilized as a co-therapeutic agent for improving the role of chemotherapeutics against the chemo-resistant cell types, cancer types.
Okay, sir. So next question says, does this breast cancer depends on some age factor?
Indeed, it is very much age factor dependent. Why the age factor depends is also because of hormonal regulation. Okay, with the age, when the hormonal levels goes down, there are studies which have shown that it is a cofactor factor for the development of the breast cancer. Mostly what we see is the postmenopausal women, they develop out more and more breast cancer because of the reason of the lack of certain ERPR hormones, estrogen progesterone hormone.
Thank you, sir. Sir, the next question says, which tumor tissues turn into cancer?
All tumor tissues will turn into cancer. Tumor tissue by per se means there is a cancer. Tumor is a phenomena where what we call in biologically, tumor is a mass of cells which are proliferating much higher. And why the cells proliferate? Because they lack the checkpoint of cell division in the tissue. So a cancer is developed. Cancer is a disease phenomena, and because of lack of checkpoint protein in the cells, they develop into cancer, and with that develops into the ball of cells that is called as tumor. I mean, in a sense, like that develops into tumor. Indeed, to answer this, yes, tumor tissues are cancerous. They can be benign, they can be malignant, depending on the stage of the cancer. As I've shown you, that stage 0 is a benign tissue, but it is a cancer. It can be cured. But higher the stages, it becomes more metastatic. It travels to distant regions, and they become more and more difficult to be cured.
So the next question says, what's the primary symptoms of breast cancer?
Primary symptoms, I am a basic scientist, but I can only say from the knowledge what I understand. Clinicians will be very much right to explain that, but there are lump formations in the breast. That is the first sign and symptom of worrisome, that everybody should go for mammography to find out whether or not it is cancerous.
And the last question says, in some cases, stage 1 remains silent. Then how can we identify them?
Indeed, stage one, sometimes I won't say they remain silent, but they are curable. Okay, so once they are curable, they are identified by various different biomarkers. So nowadays there are various different techniques which are being performed in the clinic, which are non-invasive. Uh, or tissue biopsy is done by various different methods that can define the stage. And if it's an earlier stage, it is curable. It is very much curable, and there are various success rates are very high in the clinic for curing those stages.
Thank you so much, sir. We are really very humbled for your valuable talk. It was really amazing. Thank you, sir. Thanks a lot.
Thank you. I'm very happy that you have given me the opportunity. I thank you very much.
Thank you, sir. Now, I would like to welcome the last speaker of today's webinar, Professor Swapan Majumder, Department of Chemistry, Tripura University, Tripura, India. But before this, let me introduce her to the audiences. Professor Majumdar pursued his BSc in Chemistry Honours from Tripura University, MSc in Chemistry from Tripura University, and PhD in Organic Synthesis from Indian Institute of Chemical Biology, Kolkata. His research experience in abroad are postdoctoral fellow technion, IIT Israel, Kyoto University, Japan, as JSP as postdoctoral associate, University of Ottawa, Canada, as Canada Hope Fellowship. Sir has been lecturer in Tripura University from 2004 to 2009, reader from 2009 to 2012, associate professor from 2012 to 2015, and professor from 2015 till date. He has published 53 research papers, international journals including Journal of American Chemical Society, Journal of Organic Chemistry, RSC Advances, Tetrahedron Letters, Organic and Biomolecular Chemistry, and so on. Sir has guided PhD students, and out of them, 4 has been awarded, 2 submitted, and 5 already registered. His area of research interest include green chemistry, solid supported catalyst, solvent-free reaction, synthesis biologically relevant heterocyclic compounds, novel route for carbon-carbon bond forming reactions, and development methodology in organic synthesis, synthesis of novel nanomaterials for applications in memory device, sensors, etc. Sponsored projects are being funded by CSIR, DST, as ERB. Today, Sir will be saying about chemistry for sustainable civilization. Please, sir, platform is all yours.
Good. Thank you very much. Am I audible?
Yes, sir, you are audible.
Yeah. Yeah. So first of all, I must congratulate Women's College and Kabi Nazrul Mahavidyalaya, Sonamura, for organizing such a seminar in the post-pandemic situation. And I am thankful to the organizers, particularly Dr. Samhita and Dr. Amitabha Saha, for giving me opportunity to tell before the audience about the theme of the conference, chemistry, recent issues and challenges towards our society. So at the outset, I just just tell you something about before starting the presentation, PowerPoint presentation. During the inaugural session, Dr. N.C. Sharma, the Director of Higher Education, and Dr. Adhikari, Principal of Sonamura College, they are rightly pointed out the consequences and the impact of chemistry in our society, in our daily life, and obviously the things are coming, that environment issues. So I am agree with them, and last almost 1 decade I worked on the development of sustainable medium, sustainable environment for our future generation through the research in chemistry. So now I am going to share PowerPoint slide. Is the slide is visible? Hello?
No, sir.
No?
No, sir.
Yeah.
Yes, sir. Yes, sir. Now it's okay.
I am just trying whether the slide is moving or not. Is it moving?
Yes, sir. Yes, sir.
Is it okay, right?
Yes, sir. It's all right.
Okay. So in view of conference theme, the research issues, chemistry research issues and challenges towards our society, I choose the topic chemistry for sustainable civilization. So before starting, I would like to mention that I am not going to discuss in details in my research. Rather than I am interested to tell before the audience about some consequences of chemistry, chemical research, and then very little about my research at the end of the very end of my presentations. So before that, I know, I believe, and almost everybody knows what about the chemistry, but I am thinking about some different angles. And actually, chemistry research is going on, and day by day, many new chemicals are synthesized. Those have, very interesting properties and used for the used for daily life, making device and making sensors, and maybe they are used in pharmaceutical, they may be used in drugs and these things. But before doing any synthesis or design is required, and then making the synthesis, the compounds, and after that we need analysis. And during analysis, we have to take how this reaction occurs and what is the mechanism. That is one part, and that is the this part is looking at by academician. And there are some other jobs for analysts. They are doing the quality control, They are thinking about the environmental impact and what about their impact on the healthcare sectors, and also some chemicals we can use for the detection of crimes and so on and so forth. So chemistry has extraordinary impact on our society, and it has a good side as well as some bad side. Actually, chemistry is considered as a central of science, and almost all the branches of science has a link in some ways with the chemistries like physics, then different sector of engineering, forensic science, pharmaceuticals, biochemistry, medicine, and plant science, electronics, and material science, and so many things. All are with the connection about the chemistry. So chemistry is considered as a central of science, and then due to that, chemistry has great impact on all sectors of scientific research. So what chemistry can do? Actually, this question should be what chemistry cannot do. That will be the good questions. But anyway, you see from the when we are rising from the bad, we need water. So purified water is required, and because in this universe, more than 70% are water and 30% is wet lands, and some lands is usable lands and something. But out of 70% of water, 97, more than 97, 98% is not usable. They are saline water actually. And then, so we need the water treatment to get the better quality or good quality of water. We need fertilizers, that is also chemicals. We are using fuels for our daily life that are coming from the petrochemical source. Plastics, without plastic, we cannot think about it. There's LCD, monitor, and our Android phone, and there are so many now. We cannot think about any mobile phone or laptop or desktop. So the skin used for that one, that is a chemical substance we use. Medicinal and pharmaceutical science. The battery we are using nowadays, lithium-ion battery, and then dry cells and many things. So all are using chemicals. So without chemicals, we cannot go even in a one step ahead. One great scientist, it's called Ronald Bristol, organic chemist, he made a statement. He said, chemistry is the central, useful, and creative science. What he meant for central? He says central is underpinned of many other scientific disciplines, biology, geology, material science, and many others. Why is useful? Provides many materials essential to our everyday life, knowledge to better and human and veterinary science and environment, etc. Why is this creative? Because I am putting here one structure of chemicals that is not used for the isolated from pheromones, these ant hormones, and this structure is very critical structures. So it says the structure when you synthesize, you have to design and you have to do the electrosynthetic analysis or so and so forth. So it is says the creative, and last one is an this hormone we used, steroidal hormone, for treatment of any disease. In this world, this chemical markets is almost 39% is petrochemicals, and 17% is called performance chemical. That is, these chemicals used for other associated industries. 16% pharmaceutical, 11% agrochemicals. Some inorganic chemicals is also there. Some chemicals used in the textile industries. But all these petrochemicals we are getting from the petroleum source, which is considered a non-renewable. But many other chemicals is associated with other sectors that almost all are synthesized based on the use of petrochemicals, or they are synthesized from other renewable sources. So that's why without chemicals we cannot think about our modern life. This is the scenario how petrochemical is used from this crude oil isolated from the ground, and then we can use fuel as energy and for transportation, heating, and many things. And petrochemical materials, just like naphtha or some others, we use for the commodities, special chemicals, and then we can use for the synthesis of many other compounds for pharmaceutical companies. Obviously, this synthesis can be done using some chemicals isolated from the biological sources. One great synthetic chemist, is a Korean, and he won the Nobel Prize in 1990. He was considered as a father of modern synthetic chemist, and he made an one interesting statement. He said, "I am absolutely certain that synergy between research, education, and industry is one of the great aspects of modern chemical sciences, and one of the best investment a society can make in future. Unfortunately, this happy relationship is still not widely appreciated nor practiced." This happens because industries never, give their attention for innovation or innovative research. They like, they always look for their profit, their business, and so on. So they like just synthesis only, and they need the materials for making the commodities. But for sustainable developments, we need this, consequence, or their, relationship between education, industry, and research. So, I skip you. So that branches where we can, do the research with chemistry, that is called chemical science, which has many other sub branches, like chemistry of materials, where it can be natural materials, it can be synthetic materials, it can be hybrid type, means natural, non-natural, all, and it can be nanomaterials. The other side, chemistry of life, this is like dealing with the origin of life, understanding of biological process. Just now, Professor Das, he delivered a nice lectures on these mostly biologies, but without chemistry, many drugs and many chemicals I can say used for his studies. These all are, you can consider this is a chemistry of life. Then other side, chemistry of energy. So we use many chemicals like lithium-ion battery for storage of energy, and then many other things we can use. Chemistry of environment, and this is very important for sustainability because global climate changes, that is due to some chemicals which we leach or we spill in our environment. Ozone layer depletion, that is another important issues. Now it is very hot topics also. Conservation of biosphere, quality of air, water, adverse consequences and excessive consumption of environment. So there are many things, and chemistry can deal with all the issues, in one way. So so far the things I have discussing, mostly you see the chemicals we are getting. These are all through the synthesis of them in different ways. So historically, the urea, this is a one natural product. It was synthesized by Hollard in 1828. So this is the actually landmark for this organic synthesis started from in 1828. And after that, so many scientists, they were synthesized in the laboratory, like acetic acid in 1845, alizarin is dye used, indigo is dye we are still using, and that is synthesized in 1878. And glucose, what we are taking from the natural source nowadays, but that is also synthesized in laboratory in 1890 by Fisher. And later on in 20th century, many other things, this camphor we are using in our household also, in our kitchen, camphor, that is synthesized in 1933 and 1934. Then many other things, and heme protein, that is one of the important components for the life process, and that is also synthesized in 1929. And this is a vitamin B6 pyridoxine, and that is also synthesized in 1939. Then steroid, and it is in equiline. It was in 1939. So these are the synthesis is around in very beginning of 20th century, and that is treated as Woodward era, because Woodward is one famous scientist, and during his period these things are synthesized. And later on, there are many complex and challenge targets were synthesized in the laboratory, like quinine. We know the quinine is used for the treatment of malaria, and cortisone still it is using as an birth control pill and many other things that we use. And then reserpine, we know why it's used for the reserpine. And then penicillin, antibiotics, different prostaglandins, all are used. All are complex natural products, but these are synthesized in laboratory. I will tell you why we need to synthesize them in the laboratory after 1 or 2 slides. And then there is a scientist, I already mentioned his name, Kore. So he also involved in the synthesis of very complex natural products. And then also there is another slide, and here you can see many things. Thromboxane, very important enzymes in our bodies, and then prostacyclins, prostaglandins, and many things he used. And these are synthesized in the laboratories. And another big boss is Casey Nicolai, and he also synthesized prostaglandins. This is one biologically important enzyme component. It is synthesized instantly while we need in our body paternal, many antibiotics, and then many things, vancomycin. You see this structure, very complex, but these are synthesized in the laboratory. And Taxol, another important, is used as an anti-cancer drugs, that is also synthesized in the laboratory. So during the synthesized, why we have to synthesize these things in laboratory, although they are occurring in the nature? Because this, say as example, is the Taxol. It is used in the chemotherapeutic to treatment of various cancer. But to get 1 kg of Taxol, we need around 2,000 to 3,000 matured the tree where we can isolate the Taxol. There is a 4 different types of yew tree, Pacific. It is European, Japanese, and Himalayan. Himalayan one means this is available in India also. So we need 2,000 to 3,000 mature tree, and from where we can get 900 kilogram of dried things, and then after isolation we will get in 1 kg of Taxol. To meet the high demand in worldwide, this this cancer is another vulnerable matters in the health sector. So this is not enough. So scientists, they are the players like Halton, Nicolau, Denisovsky, and Onder. They try to synthesize Taxol in the laboratory. So this is the structure of Taxol. So for synthesis of this Taxol in laboratory, Halton, he completed the synthesis by 41 steps, and then Nicolau, he finished it by 51 steps, and Oender is 37 steps, and Denisovsky finished 47 steps. So this is the one target, but to reach this target or to fulfill the targets, this minimum steps is in Oender process 37, and Casey Nicolau it is in 41. So each and every steps is very crucial, and it has so many chiral centers. I hope many of audience are from the chemistry background, so they know what are the significance of chirality and chiral centers. So each and every steps is also a part of new research. So during this completion, a huge amount of waste like organic solvents, like reagents, and many things is generated. It requires heat energy. So toxic metal catalyst is required. So huge amount of toxic byproduct or waste is generated during the synthesis. This is only for the one target. Only 4 people or worked on it, and during the just in 1990s. So you can imagine around the world how many people work on on their different targets. So from the chemistry lab and the chemical industries and the institution where the chemistry people work, so huge amount of waste product is generated, and the very important issues is the disposal or management of issues. What are these? Because many of the states is required, high temperature, so requirement of energy. Where you can get energy? Energy is maybe from the thermal energy, maybe from the nuclear energies by form of electricity. So required volatile solvent. What is a volatile solvent? Chloroform, dichloromethane, ethyl acetate, methanol, ethanol, and many things. Toxic metal catalyst is required. Large amount of waste is generated. Use of material, those are originated from petroleum. So petroleum is considered as a non-renewable source. So one day it will finish. So that is the one big issues. And hazardous nature of substrate or reagent or catalyst. So the waste generated from the chemical laboratory, that is the big issue, how to manage and how to dispose them. So this is the one still, one of the big issues in the waste management sector, and not only from the chemical research. This is the government policy is also implemented, but still result we are not getting the fruitful results. So apart from the waste from the chemical laboratories, many manufacturing units, they are also releasing of chemicals to our environment, and some chemicals we are coming from our household activities, and also disposal. If you dispose to the environment, some chemicals will leach from that. Like say as example, PET bottles after drinking these cold drinks, we are throwing these bottles here and there. So because of unplanned disposal systems are there. So they are, exist in our environment and create a problem. And not only now, because of PET bottles is not biodegradable, so it will stay for a long time in our environment. So these are called persistent materials. So, during chemical, conversion reactants to products. So normally A to A plus B form C, C plus D form E, or E plus F to G. But all the steps, we can do in two different, ways. One is called homogeneous phase, another is called heterogeneous phase. So homogeneous means you have to use a solvent to dissolve all the substrate, reagents, and catalyst. So you will see only one phase in there. Heterogeneous phase, the reaction is called either two different phase, either solid liquid or liquid gas or gas solid, etc. But this in the reaction where homogeneous conditions are applied, the solvent is required for that. What is the solvent? Solvent actually it is a liquid chemicals used to dissolve your solute and reagents, and mostly are derived from the petroleum sources, or they may be the synthetic source. So these kind of solvent, they have the low boiling point and they evaporate very easily, and they escape from your system to the environment to make. So these are considered, or it is treated as it's called volatile organic solvent, VOS. So these are the major threat of environment. So particularly chloroform, and then dichloromethane, halogenated solvent, benzene, or toluene, they are harmful for us. So these are the list of common organic solvent, and there is a huge number, but I am putting here the red bar on the dielectric constant, because these are the very important to control or to identify the solvent, because it's higher the dielectric constant, they are is considered as highly polar and used for the very reactions where you are using organic inorganic chemicals for them. So dielectric constant of acetone is 21, acetonitrile 36, and if you go one by one, dimethyl formamide 38, DMSO 47, and then glycerin 42, HMPA 31, and then methanol 32, NMP is 32, nitromethane 35, and at the end water you can see 78.5. So among all the solvent used, water has a high dielectric constant, and also availability in water in this universe is very high rather than this. So water is available everywhere. So to having this idea and also having these high dielectric constant values, water is considered as a good solvent for solubility of inorganic reagent. And not only that, this water is considered as safe because it is related to our life process, and it is not so much volatile as other organic solvents, and it is not because of it is connected with the life process, so it is not cause any harm to us. So if we can use water as a solvent for many these organic synthesis or organic reactions, many of the environmental issues will get solved. So people are now thinking to use of water as a solvent for organic reaction. So these are the slide where I am showing the common organic solvent used for synthetic chemists by synthetic chemists. Water I put it at the top because these are the most advantageous one, and then methanol, ethanol, this area is little bit green, and then green part is decreasing, and you see at the bottom this chlorinated solvent, they are lies in the red areas. So that means the solvent I putting in the red areas, they are most harmful solvent for us, for our society, for our environment. So water could be the good solvent in terms of if you count all these parameter to protect our environment. So what are these things are coming from industry and from some natural sources and from our daily activities, and these chemicals which are those are other volatile organic solvent or some other gases, so they are escaping from and they are released in our environment. So these are treated as a pollutant emissions. So our environment is get polluted due to this gas, and then CFC of course or another issues. So when they release the environment, they are spreading throughout, not they do not have any boundary, not border or nothing. So if something pollutant is releasing from India, they can go to the Pakistan, they can go to the Bangladesh, they can go Arab, and they can go anywhere. So this makes the creates a problem, because this kind of release, since they are the lighters, they goes in the upper stratosphere and they can destroy our ozone layer and many things. So these are gases is considered as global warming and ozone layer depletion chemicals. So that is one issues. So here are the almost this contribution for this kind of release from industry is 52%, because industry is a industry means major chemical industries, and then many other things like agricultural sector 10%, commercial, residential from only 1%, consumer commercial products 8%, transportation means vehicles because it used petrol, diesels or others, LPG, CNG or so. So after combustion, carbon dioxide is releasing from that. So they are releasing our environment. So increase the temperature of this our environment. So considered as a global warming also. So they are called greenhouse gas. So not only air get polluted, water bodies also can get polluted from the disposal of chemicals, and like sea waste, industrial waste, and then during flood, and then without unplanned disposal of many household goods or used goods here and there, and then construction materials, and then many things. So our land, our water, our air get polluted, and all the things, some chemicals are responsible for that. So this way, there is a one concept in this: chemistry versus chemicals. Chemistry is the only we are chemistry peoples. Only few percentage are there. But without chemicals, one civilization cannot survive. So chemicals, they are they have a bad press on everybody's because we are in the morning we are taking milk, we are taking breakfast and many things. So these are also chemicals. So but common people, they are not thinking this way. They are thinking this is as our food, and only just like bleaching powder and then pesticides and herbicides, they are the chemicals. Actually all of these chemicals, some are good, some are bad. So the things we are releasing our environment, we must control that to protect our environment, to protect our future. So here I put some list of chemical disasters. So this happens in this earth. In like 1917, there is a ammonium nitrate container that explodes in Halifax, Canada, and Minamata disaster. Many of us we know what is Minamata. That is just unknowingly people's these industrial people, they throw the mercury disposed in the sea areas. So this entered in the food chain of that areas. Minamata disaster, then Texas city disaster. Couple of thousand of people died during this. Even almost every day, this kind of events things are happen around the globe. So many people that died almost every during pandemic situation also. In Odisha, this Vizag, there is a one chemical plant, some leakage of gases, and a couple of people have died. Chernobyl disaster, this is an disaster connected with the nuclear plant. And Beirut disaster, it is just recently 2020. That is also explosion of ammonium nitrate container. This was carried from seaport to the chemical industries, and ammonium nitrate is used for the in the industry where the fertilizer was synthesized. So this kind of disaster have several impact in the living organism as well as our environment and properties. Living organism like humans, livestock, plants. So it causes death, injury, disease, and disability. Even this kind of disease and disability, it can be propagate, in the hereditically also next generation, and then maybe in the second, fourth generation also this can happen. Our environment like soil and water bodies also can get polluted, and atmosphere can get polluted. So major industrial hazards are generally associated with this potential of fire, explosion, and dispersion of toxic chemicals, and usually involved in accidental release of chemicals from contaminant. So accident also involved with the major hazard, as I've shown in here in this slide. So therefore, we can conclude that chemistry has an important role to play in achieving a sustainable civilization on Earth. If we are able to control this kind of things, we can have better life, and we can put this Earth for our future generation and for the next generation also. So, but what is sustainable civilization? What is sustainable So in a sustainable civilization, actually it means this technology used for the production of needed goods are not harmful to the environment or to human health. We must use renewable resources such as plant-based substances or solar energy rather than those like fossil fuels that will eventually run out one day. It was estimated that in 2050, almost all fossil fuels will get gone. So, to having in mind this kind of impact for our future generation and for our art. The green chemistry concept, it was coined in 1990. So what is green chemistry? These are the colors of chemistry. This green chemistry means it is just meaning something different. We say it is a sustainable chemistry, chemistry that is benign by design, pollution prevention at the molecular level. So to maintain all these criteria, we have to follow some guidelines, follow some rules, and these are actually a philosophy. So we have to, if we maintain this philosophy, what is philosophy? Here is the 12 principle. It says green chemistry, prevent waste. So if we can prevent the waste generation, then so many problems will be solved. Maximize atom economy. Atom economy, this is the term used for the chemical reactions. If all the atoms appeared in the final products from the substance and from the reactants, so these are known as the 100% atom economics. And we know only few reactions, chemical reactions are 100%, maintain 100% atom economy. Because of waste generation during the process, it decreases the atom economy. We must use less hazardous chemical synthesis. We need safer chemicals and products, safer solvents, as I mentioned earlier. Increase energy efficiency. So the reaction, which is just if it is follow or if it is happens in the room temperature, that should be good as the some reaction which requires the high energy. We must use renewable feedstocks. We must avoid chemical derivatization during the fulfill of the targets. Use of catalyst. So catalyst will decrease the reaction time and increase the yield of the reactions. So we must use the catalyst, and catalyst should be environmentally benign, and it should be metal free, because if you use metal catalyst, then they will create another problem. So design of chemicals and products to degrade after use, and analyze in real time to prevent pollution. Computerized analysis, what is the impact of this disposed materials. And then number 12 is minimize potential for accidents. So we have to design all the chemical synthesis to having in mind all these principles. It is maintaining the green chemistry, or it is commonly known as principles of the green chemistry. So here, the two important journals, green chemistry, this is one important, a very high impact journals. They are publishing the results related to green chemistry and for sustainable chemistry. Another journals, this is from the Royal Society of Chemistry, and another journals is called ChemSusChem, Chemistry and Sustainable Chemistry. That is from the Wiley Group from Europe, and it is started. They started publish their works in first issues appeared in 2008. So they are publishing works in connection with the synthetic chemistry or the synthetic process, which are having this, all the aspects of green chemistry. So to make any process is environmentally benign, so we must have or we must have in our mind the reaction should be in ambient temperature with solvent, or if it is a solvent-free reactions in water or water. reaction under grindstone condition. That is actually nothing but, motor or pestle we are using the laboratory. So if you grind all these things, motor or pestle, if reaction happens, so you are using your, energy for this reaction. So you don't need to have, any electricity or any mechanical energy for that. Catalytic reaction or recyclability of catalysts. This is another point. Metal-free conditions, avoiding hazardous reagents, and there are many ways. And ball milling process, polymer supported reagents. If you use polymer supported reagents, you can recycle the reagents because it is a polymer, it is not soluble in anywhere. So after filtration, you can get it back and can be used for the next cycle or another reactions. Using ionic liquid, I will show you what is ionic liquid. This is a very specialty chemicals. And using microwave, we use microwave for in our household purpose, but some chemical process can be conducted under microwave conditions in so that you can save energy and time and many things. So whatever the our philosophy or our guidelines, whatever, but this should be this is one important statement by Plato. He said necessity is the mother of invention. So invention, when it is say as example, if any machines as more steam powered machine were built, so factories needed more coal to create this steam. So if you have more power, so you have to give the more steam. That means you need the more coal for that. So to meet this demand, the mining methods to be improved to meet the demand for more coal. So this is the necessity. We need more coal. So to meet that, we have to be more innovative. So this is coming. This is inspiration is actually a necessity. We need it. So that's why the process of inventing never ends. It never ends. It is continuing process. So one invention immediately leads to improvement upon it and to more innovations. So inventing process, I have shown that, first organic synthesis, it was in 1828. It is from ammonium cyanide to urea. So, but still that kind of, process is going on. So historical landmark is at 1828, but still is, the process, each and every process have some advantage, and it is actually put forward for the another invention. So here, this is the structure of ionic liquid. As I said, that is the specialty chemicals. So ionic, normally ionic compound like sodium chloride, sodium bromide, potassium iodide. So they are inorganic compound and they are high melting solid. So ionic liquid, the term ion is there, but this ionic is an organic cations are there. This is a very big organic part, and inorganic part is very small. So they are, even though they are ions, but they are liquid in room temperature, or they get liquefied in below 100 degrees Celsius. So they have their unique features for this reaction, like catalysis of reactions. They can recycle, regenerate, and many things can happen. Can do with this ionic liquid. So since these are not like an inorganic chemicals like organic, so they also help to solubilize some organic compounds on the, even though organic compounds are not organic compounds are in covalent in nature, but they can soluble in this ionic liquid medium. So they are considered as an benign solvent for organic synthesis. So these are all are the like you said, nitrogen gets positive charge. So these are all ionic liquids. And another type of catalyst is called solid supported catalyst, like resin and polymer supported catalyst or silica supported catalyst. So they are also considered as environmentally benign because they are not soluble in anywhere. So you can filter and recycle and regenerate for the use of the other reactions or the same reaction in same next cycle. So apart from that, ionic liquid or solid support reagents, if you wanted to do the reaction in water, as I mentioned, is various features in terms of impact in our life, like environmental, safe, and then easily available, very cheap, and many the advantages are associated with the water if you use as a solvent. Since its impact on our life is absolutely nil, so that's why it is considered as a green solvent. But problem is that if you use water for any organic reactions, because water is a polar solvent and your organic compound is a non-polar and in nature, so they are not get they are from the immiscible layer, so they cannot be mixed. So very difficult to do reaction in water with the organic substrate or reagents or catalyst. But using some mechanical standard, so you can rotate all these things vigorously. So sometimes in some cases reaction can happen. So product, if it is solid, it gets precipitated and water layer is there, so you can filter and you can collect this reaction. But these are the very limited reactions are there where directly water can be used for this. So vigorous studying is required for this. So mechanical study is required, but its success is limited because of insolubility of the organic substance in water. As example here, I can do this is a long chain alkyl chloride. If you use sodium cyanide, nucleophilic substitution in water, it has no reaction. So some technique was developed later on. It is an quaternary ammonium salt. If you use just like a 1%, 1 mole % of this on this reaction, and within 2-3 hours, this 100% reaction yield is. So what is the role of this quaternary ammonium ion? Because quaternary ammonium ion, it is soluble in water, and it has a very 4 alkyl group on this. R4 means 4 alkyl group. So it has an interaction with this carbon chain. This is called hydrophobic interaction. So this quaternary ammonium salt helps this compound to get soluble in water, and their reaction happens. So this quaternary ammonium salt, it is known as a phase transfer catalyst. You can need only 1% as a catalyst. So you can do the reaction in water using this kind of phase transfer catalyst. So this is one way to do the reaction in water using the phase transfer catalyst. And apart from that, another very important compound that is termed as surfactants. Surfactant is known as a surface active agent. Their main features is they have one hydrophilic head. This is an I put it in the ball, and then they have the hydrophobic tail. So these are the common structure of surfactants like SDS or sodium dodecyl sulfonate and very others. These are they are the structure. So these are called anionic surfactant. This is one category. This anion, which is an anion, and very small cations are there. There is a long hydrophobic chain. So this is called anionic surfactant, sodium dodecyl sulfate, SDS. And cationic, there is a cations are there. Nitrogen is cation. Very long chain, hydrocarbon chains are there. Small methyls are there. Cetyl trimethyl ammonium bromide. This is also considered as a surfactant, but it's called cationic surfactant because cations is associated with the hydrocarbon chain. Similarly, pyridine, if you use pyridinium surfactant is also possible. amphoteric surfactants is there. Actually, this kind of surfactants is also associated with our life process also, because when lungs, expand or its size is decreasing during the respiration process, these surfactants are, involved on there. Even we use surfactants to clean our clothes. The soap, detergent we are using, that is also actually one kind of surfactants. So some surfactants, these are called non-ionic, like this. So they have the polar hydroxy there, and these are the non-polar part. So these kind of surfactants, if you put it the surfactants in a very small amounts in water, so what happens? This water is the polar, so they interact with the polar head group. So all head group, they lies on the surface of the water layer, and tail part, hydrophobic part, they are in the out of this. So they form a layer in the top of the water. So, but if it becomes saturated with this surfactant, so that means you have to have some concentration. What happens? Say first beaker, you see this and that. So if we increase the concentration of that, increase concentration, so some of the surfactants goes inside and they get aggregate because of this medium is polar. All head groups located in the outside, and tail group, those are the hydrophobic. They form the hydrophobic interaction. So they form a aggregated structure, and you see there is a nicely they organized in this medium. So after formation of this kind of aggregate, inside they form a cavity. Inside they are the hydrophobic, and outside is hydrophilic. So, but there is some empty space inside the this kind of cavity. So, as a result, say these are the plot total surfactant concentration versus surfactant monomer concentration. So you increase concentration increasing after certain, when you reach in certain values, all the surfactant will get formed this kind of aggregated. And after that, even if you increase the concentration, surfactant concentration, it will not change. So this point is called CMC, critical micelle concentration. So that means in this concentration, you will get the maximum, aggregated structure of this, surfactants in that medium. So when they form this kind of aggregated structure or CMC, what we can do with this? Look, this is the whole slide. These are the monomer in the polar solvent. They can aggregate and they form the spherical micelles. This is called micelles. So this is the just one type, and then if more and more associated, you can see the cylindrical side. It is a cylinder type. So inside that, this is an free passage. In even though there is a hydrophobic tail is there, but still there is some empty space there. So if you just do the cross section, so there will be like layer like things also there. So inside there is a free passage for hydrophobic molecules. But in the non-polar solvent, opposite things can happen, because non-polar outside is the hydrophobic. So tail coming outside, head going inside. So this kind of things also happen in the non-polar solvent. That is not our interest, because non-polar means either chloroform, dichloromether, or something like that. We are not interested on here, but it also happens. That is called reverse micelles. So our interest on the formation of micelles and how we can use these micelles for doing the organic reaction on water. Let's see. So surfactants, mediated organic synthesis. Because surfactants is very easy to prepare, easy to and very cheap, and they form the due to the hydrophobic, hydrophilic interaction. So these are one thing is called supramolecular interaction. So we can use these surfactants to get soluble in organic compound in water. What is this? Take the water, take organic compound. This will be organic compound will be insoluble. So where do you increase this, concentration of surfactants? At micelles concentration, there will be several micelles will form, and since micelles have the, in their core there is an empty space which is hydrophobic. So this hydrophobic part can catch hydrophobic organic molecule inside the water. Look, none of the organic compounds are free in this media. Everything is get soluble due to the formation of micelles. So what it means? It means you can you will be able to solubilize your organic compounds in water. Now, if you have some reagents which is water soluble, so they can enter inside the micelles and then doing the reactions and then can be coming out. So this kind of micelles or colloidal dispersion that is very useful for many organic reactions, and nowadays many people are working on that areas and and to synthesize many useful materials. So how I will know that this micelles is formed, and that micelles, what is the size of that micelle, and what is the cavity size, whether it will be depending on this hydrocarbon or the chain length on that. So there is one device instrument that is called dynamic light scattering instruments, DLS. It is very commonly known as DLS, and DLS studies can tell you the formation of micelles and what is the size of that micelle. So these are the actually this phenomenon inside, but you need only sample for that. You put the sample inside, and this instrument will measure due to the laser light using of there, and see the dispersion things are formed inside the media. So light will be absorption and then emission, then some detections there. So it will detect the particles available in that media. So from there it will be count that it's what is the size of that micelles in the nanometer, micrometer, or whatever the size. So so you will be able to know the size of the cavity, and then you will be able to use that cavity for many organic reactions. So here I just put example from the work of others. Acid and ester, we know that acid and alcohol, they form the ester, and that ester formation is irreversible due to the formation of water. So to make the process irreversible, we have to remove this water from the system. So that is one drawbacks why alcohol and ester alcohol and acid not directly from ester. We need some activators and then some other reagent to make an ester from acid and alcohol. But if we are able to remove water from the system without using any catalyst, this reaction can happen. And this was done by this surfactant catalyst media, when this CMC or this micelles is formed at CMCs. So acid and water alcohol both are organic, so they enter inside and they react each other and water is formed. Since inside the cavity is hydrophobic, the water generated so from this reaction, instantly it come out. That means water is coming out from inside to outside. So reaction it proceed from the forward direction. So this was very beginning of this century. In 2002, it was published in Journal of American Chemical Society. So they are the actually pioneer work on this micelles, interpretation of micelles in organic synthesis. And now I am going to show my only couple of research work on these areas, micelle mediated organic synthesis. We are almost very end of my talk, benzimidazole, this structure is showing it as a one, very important compound for biology, for chemistry, for material science, or many things. So if you can able to replace this hydrogen by alkyl, that is also having another impact, or can be used from the different types of many materials. So alkylation is a one important way to replace this hydrogen by alkyl, and this reaction can be done using sorry. So by using an organic solvent, and but we are interested to carry out this reaction in water, either in room temperature or maybe in the little elevated temperature. So we used SDS and then alkyl halides and then 50% OH. So we are very happy that this kind of alkylation happened in water without adding any organic solvents. Obviously, if we vary the reaction condition and that things, this benzimidazole ring can open, we can get the different types of compounds. But this is an amine and amide in the same molecule, so that is also having very interesting properties. But my concern is how to do why this reaction happens in water SDS. Here also again we are believing that there is a mycelium formation, and then benzimidazole, and then this one going inside the cavity and forms the products. And this kind of mycelium formation we also cross verify by DLS experiment. Here is the one graph. It means if you add water and SDS without any addition of substrate or reagent, DLS says 190 nanometer is particle is formed in the medium. So that means SDS formed in mycelium in water whose diameter size is 190 nanometer. But when we add other things like sodium hydroxide, benzimidazole, and alkylating agent at room temperature, this size is going to 574 nanometer, almost threefold size increase. That means how this size increase? Because benzimidazole, benzalbromide, they now entered inside the cavity, and as a result, they inside in the cavity. As a result, this cavity diameter of this mycelium is got enhanced. So even if you heat it now, so if you heat, that means the more molecule will go inside the cavity. So size again increase in 780. So this study indicates that mycelium is formed, and due to this reaction occurs inside the mycelium, and we are able to alkylate the benzimidazole through this surfactant induced method. So during this alkylation process, we have also alkylate imidazole by using this hexadecyl group here. So we synthesize this hexadecyl group. So we are interested to apply this kind of molecule because it has two nitrogen. One is basic nitrogen, another is a nitrogen. It is a part of the aromatic ring. So two nitrogen has a different behavior. So we have this one in our hand. We got this one by synthetic method. The other side, this kind of polyacetylenic compound having the carboxylic acid group, it is an acid. So this we purchased commercially from different companies because this acetylenic compound, it has it shows the interesting properties. If you place this compound in UV light, it undergoes polymerization. So that's why we are interested to use this one to make some polymer which can be used from the different purpose of material science, like electronic or preparation of sensor or something. So what we did, we used this one, this first one, and this white color. This is a one kind of paper, and it was coated with some clay that is called hectonite clay. It has a layer on that, and we place this clay containing paper to a solution of these two, A and B, and we got a thin layer of that acetylenic compound, and that imidazole on this paper. So as we know that this acetylenic compound get polymerized under UV radiation, and after polymerization it shows the blue color. So this white paper, it instantly shows UV exposure, it shows the blue color. So blue color indicates that polymerization is completed. Now, after getting this polymerized thin film, we put this thin film to a beaker having some volatile organic solvent, and we place there. So this film here, and we just covered this one, and because this lid inner surface, we just attach this paper, and just we covered this beaker with that lid. And after some times, we observed that this color has been changed to red. Not only that, different colors, based on the times. We have seen that is so visibly you can see this color changes, 1 minute, 2 minutes, 3 minutes, or something like that. So this means these polymerized species, which is generated by UV exposure, and then or imidazole, and then diacylonic compound. So that means this kind of it can be used as a sensor for detection of volatile organic compound. So we have taken exhaustive studies with different volatile organic solvent like hexane, dichloromethane, or many, and we have seen that it responds differently with each and every solvents. So based on that, we just designed for detection of this sensor for petrols and for adulterate petrols, because many petrol companies, they used mixed with kerosene, and then maybe diesel or something like that. So when pure gasoline petrol is used, because petrol is a hydrocarbon having the carbon number from 6 to 8 or 9. So pure petrol, it can be detected, and it shows the color changes from blue to red. But when some kerosene is added, there are certain percentage, like more than 5% with this petrol, color is not changing. So because petrol is hydrocarbon, and diesel is also hydrocarbon, kerosene is also hydrocarbon. But when you used less volatile kerosene or diesel with the petrol, its volatility gets reduced due to the hydrophobic interaction. So these are not, this adulterated gasoline is not considered as a volatile organic solvent, because its volatility gets reduced due to the presence of this mixed diesel or kerosene. So VOC is detected. Now, when we get this information, then what we did, we used this paper coated with this polyacetylenic compound. We placed that paper in front of the exhaust of vehicles, in here, because we know this nowadays this pollution certificate is to be required for each and every vehicles after every 6 months. So when we see the certificate from pollution center, we see they measure amount of carbon monoxide and they also measure amount of hydrocarbon. So that hydrocarbon, but especially unused petrol, which are leased from the system, or sometimes some benzene vapor. So we expose that paper on the in front of this exhaust, and we find that this paper is changing color depending on the nature of vehicles or the age of vehicles. So we can think, okay, that can be used for the sensor for the detection of hydrocarbon or automobile exhaust. So yeah, this one. So for that study, we picked up 2 vehicles. One is a car 1, another is car 2. So car 1 is in 4 years old, and car 2 it was 10 years old. So certificate we got from the this pollution center. This petrol, this hydrocarbon for that particular vehicle, because that is an I think modern car, that is Euro 4, most probably, that limits, they said, to 100 for hydrocarbon, and it value 113. So value 113, and it is a ppm. And for the other one, which is 10 years old, that value is prescribed form is different based on the age of this car, but these values will be the that will not vary. This is an 161. So that means the car 2 polluted little bit more than car 1, because it is an 113 is in hydrocarbon emission is 113, that is 161. So from that, now you back to our experiment. Initially, this is blue, and then 30-second exposure, 1 minute, 2 minutes, 4 minutes, and 6 minutes. So you see this color is changing. This is the threshold limit, 6 minutes. And then other one, blue, then this color, you can see the difference of color here. After 6 minutes, you can see that this too. So this kind of color you can analyze by computer, right? Like RGB method, you can analyze, and then you can quantify this how much hydrocarbon has been absorbed by this thin film in the paper. So based on that, we can make a device. So, but we did not perform that device preparation or device synthesis. So we did only up to this one, and we got the publication on this work. So we believe that the chemistry behind that this color changing. So this is normally when you expose diacylinic compound in UV, this kind of polymer is formed, and due to this polymer formation, they form the blue color. When volatile organic compound is come, this is without imidazole. So this should be remembered. This is without imidazole. So these are these volatile VOCs entering this head group interaction, because either hydrogen bond interaction or maybe ion dipole interaction, dipole interaction is also there. But without imidazole, this was not successful because the film was unstable, and we put this film for 2 days, and we found that after 2 days this color is gone. But when we prepared a film with imidazole part, so there is a strong hydrophobic interaction. This film becomes more packed, and then when it interact with the volatile organic compound, so they again interact with this part, and this film color absorption is become more stable, and we can keep it for a long time. So that means this thin film is more stable here, and with imidazole moiety, this film is more stable, and we can make a device for this one to detect volatile organic compound existing from not only from the vehicles, maybe from the other research institute or many other places we can use. So here I am showing, you see, we start from the synthesis of analylated these materials, imidazole materials by environmentally benign method, which is considered as sustainable, and then we applied this one to make a device or to design a device where we can detect the volatile organic compound so that we can protect our environment. So this part is very interesting, and we published in JPCC and very recently. So here also this some other words here I am describing. We can use in SDS and water, and that is also reaction occurs in the micellar conditions. This is just an this is called Henry reaction of addition of nitromethane to the carbonyl. So nitroaldol you can synthesize. So obviously this kind of reaction, it is known in using the organic solvent, but using SDS and other ionic liquid combination which in water environmental benign conditions, this is not explored earlier. So we did it and we published in the chemistry select in 2019. And similarly, we also did some novel agent condensation. That is also novel agent condensation is also very known. And various catalysts earlier was used titanium oxide, zirconium oxide. So there are many things. All are metal mediated or other organic base is used, organic solvent is used. So this reaction is known. But we did that in the same fashion using SDS and ionic liquid as a promoter for this reaction. And we did this novel agent condensation with cyanomelonitrile or cyanoacetic ester. We got the alpha beta unsaturated ester without using any organic solvent. And not only that, after first cycle, we collect all the waste, and after filtration of solid products, we collect the waste and we use for the next cycle the same fashion. Here 96% yield. You see the waste we did not throw in the environment or not in the disposal box. We collect it and we use for the second cycle. So same efficiency we found. Third cycle also same. And fourth is 95%, fifth 96. I guess this is an human error. So you see all the this catalytic efficiency of this SDS and ionic liquid water can be preserved throughout the reaction. So waste disposal problem for this particular reaction you can solve. You can keep it for the or you can use for this reaction for future also. So this is one application of this novel agent condensation. So this is the alpha beta unsaturated nitrile. So another nucleophile can attack on this one. So you can get diverse functionalized molecule. You have amino, you have cyano, you have pyrazole, and many things are pyran, pyrazole. So this kind of compounds have a biological activity. So we can synthesize from this method by circumvent of the side reactions. But remembering this reaction in the whole reaction we conducted on water using SDS, and then so we believe that the micellar micellar is formed in this reaction, which helps to get solubilize the reaction, and then. So we are almost in the very end of my presentation. So what we learned from this presentation, because I have focused the things targeting our UG students, undergraduate students, those can join research program in future, so that they can have their own mindset of what to do and how to handle with chemicals and so on and so forth. So what are the benefit of if we practice the sustainability or in chemistry? So The environment and societal benefits of sustainable chemistry includes avoiding the use of persistent, bioaccumulative, toxic and hazardous materials, using renewable resources and decreasing consumption of non-renewable resources, minimizing negative environmental impact of chemical process and manufacturing, providing technologies that are economically competitive, competitive and advances to industry, and waste management, proper disposal, recycle, reuse of materials that are the important one. So we must, look on green use of green catalyst, green solvent, renewable, source of materials like, like feedstock, agricultural based products, and then efficient process in terms of energy. So solar energy we must employ it, or we try to employ it for that one, so that the process will be highly environmentally benign. So we must, encourage the use of products which is the benign, so that the if something exists to the environment, it will not cause any harm to our environment. So thank you, everybody for paying attention. Uh, the lecture. Thank you very much.
Thank you so much, sir. We are really humble for your valuable talk. It was really amazing. So now some questions from the audiences. I'm just showing the questions on the screen. Hello, sir. Hello, sir. Sir, are you there?
Yeah. Hello.
Yes, sir. Sir,
Yeah, yeah. I lost this connection. So,
okay,
okay.
sir.
Any
So some
question?
question, sir, some questions from the side of the audiences. The question
Yeah.
says, sir, can shape memory alloy be categorized under sustainable development?
Uh, Not all kind of allies. Not all kind of allies. If it is like, mercury allies, that should not be. So
So not
this,
the effect of the shape memory alloy, the new technology, or that thing can be categorized this under sustainable development?
yeah, of course, that could be, but anything, because say if you fly to, airport, you can carry, your lithium ion battery, but they will not allow you to carry, match sticks. Okay, because
Yes, sir.
match stick is very easy to, use for, explosions or many things. But this lithium ion battery or your laptop battery, it is designed such a way so that it is not generally, it not cause any harm or not exploit. So that is the things you can use that kind of, say in a nuclear power plant, we are using, radioactive materials and these things, but we're taking high precaution on that areas. So you can use anything, but you should be always, remember that it should not be leached to the environment in any case. That's the issues.
Okay, sir. So thank you. So one more question from the side of the audiences. Sir, it says, does detergent causes pollution? If yes, what can be the alternative for this?
Yeah, of course. Say SDS, sodium sulfonate or benzene sulfonate. These kind of detergents available in the market, which are very cheap also. So basically, they are causing, environmental pollution, of course.
Yes, sir.
But there are in the market, there are some, some detergents is coming, and they are designing using the bio-based products like aloe vera, and that the many things are coming in the market. So that kind of,
Yes.
detergent can be, we can, I mean, research is going on still on that areas.
Okay, sir. So thank you. So one last question from the side of the audiences. As student, what can be the ways or what can be the steps taken to reduce global warming through sustainable development?
Yeah, actually, this is the issue in the global warming, and main reasons is people are taking the carbon dioxide, release of carbon dioxide from the vehicles is the major issues. So that's why people are thinking, scientists are thinking about using hydrogen as a fuel. Okay, because they are thinking hydrogen after burning, hydrogen will form water, and it is not reaching the environment, and so you can reduce the amount of carbon dioxide released in the environment. That is okay. But when this water will come from the exhaust from the engine, it will come as a vapor. So this our environment will, water vapor concentration will get increased. So still you suppress the amount of carbon dioxide, but still you will input another culprit, which is also responsible for global warming. So
Yes, sir.
we should be everything is relative. Relative means both are culprit, but which will cause more harm. So carbon dioxide will cause more harm than the water vapor. So that's the way we can think about that.
Thank you, sir. Thank you, sir. Thank you so much. Sir, it was really very much informative, and thanks for your valuable time that you have shared with us. Thanks a lot.
Okay, thank you very much.
Yes,
Thank
sir.
you, Amitabha. I can see
Uh,
you. I can see Samhita. Yeah. So thank you all.
so here the technical session comes to an end. Now I would request Dr. Amitabha Saha sir, Assistant Professor, H.O.D, Department of Chemistry, Kabi, Nazrul Mahavidyalaya, Sonamura, Tripura, who is also the Joint Secretary, Organizing Secretary of this webinar, to carry on with the valedictory session. Over to you, sir.
It is our great fortune that there are three eminent speakers that they are accept our invitation. Dr. Paresh Chandra, Professor, Department of Chemistry and Biochemistry, Jackson University, USA, who delivered a lecture on bioconjugated nanomaterial for targeted diagnosis and inhibition of COVID-19. Our second speaker was Dr. Amitava, Principal Scientist, CSIR-IICT, Hyderabad, India, who delivered lecture on to be or not to be transcription factors as target of cancer therapeutics. And the third speaker of the day was Dr. Swapan Majumder, Professor, Department of Chemistry, Tripura University, India, who delivered lecture on chemistry for sustainable civilization. On behalf of organizer, I express my sincere thanks to all of you. I hope that we shall meet again in near future. Thank you. Having a good day.
And, and,
And